think some of you, many companies, big and small MNC or mid-sized companies, are actually implementing or considering, to go transform into a digital world. Okay. So, but when we do this kind of transformation, digital transformation, the essential things to consider, not only technology, we have to really look into processing, which is very important, just like we do ERP or supply chain system. You have to consider processes. We also have to consider organization, which involve people, collaboration between function of department, and system integration, so forth. By looking at some of the management techniques like Lean, Six Sigma, EQM, you have, I think there's a big synergy between these into smart manufacturing that we can actually make it quicker, in the implementation. Your process will be more optimized and efficient. So let's look forward and look into whether these management techniques like TQM or Lean principle can actually help us to move forward to this transformation journey into a leaner, smarter, and more efficient future. Okay. Sorry for. Okay. Okay. I'm not here to go through this industrial revolution. I'm sure a lot of you already knows the industry revolution. But what I want to actually share with you, actually, the shift from one revolution to another revolution, which is actually delineating the major shift in economic and industrial activities, is actually driven by technology advancement and the methodology. Okay, so for example, in the first industrial revolution, we are dominated by craftsmanship, making one product only, make to one product and really craftsmanship and all these things. Then second industrial revolution is actually introduction of the assembly line. Then it comes out that mass production makes production into a simpler task, and then can make a lot of products at the same time, where the car manufacturing for everybody is familiar with. So mass production, these techniques actually really dominated, in the second industrial revolution. In the third industrial revolution, then when we have IT, automation, computerization, go into the shop floor. Okay, then we come in a lot of other things like okay, sorry, can't see. Then we come in a lot of things about PQM, Lean. Lean the times actually come in as a management tools or techniques to help us to enable or leverage the technology into moving into a better transformation. Today, fourth industrial revolution is actually talking about cyber physical system. So we're talking about, again, how to actually use these management techniques to go into a better digital, smarter, leaner kind of industry or company, But what is really common here, when you looking at the first industrial revolution to second, third, and fourth, is the technology changes and the methodology changes. Okay, from mass production to TQM to lean and agile and all these smart manufacturing. But what is really common here is that the flow and the variation is still the same. We're still doing how managing our flow, how to manage the variation. The flow is actually the continuous efficiency and smooth movement of goods, information and services from one point to another point within the process, within the factory, within the supply chain, even the financial. That is the flow. That's why Lean actually talk a lot about flow. Where flow is different from sequence operation. Your sequence operation, Lean talk about value add. Everything must be, every segment must have value add, but the flow must be there, synchronized. Okay, so the question comes here. The challenge is that how there's a variation. Okay, so second is a variation. Variation means the interruption, the bottleneck. It happens in our daily life. It happens in our factory and all these things. So this question coming is how we can effectively managing the flow and the variation. And this is a 4 dimension of a success factor of operation management. QRC. So the quality. So does every product works? So we need to manufacture a product that meets the customer needs or the market needs. So can we meet the demand? Is our capacity or our flow, our rate and our capacity can actually meet the demand? Do we have the capacity? Can we produce enough for the market? That is can we meet the cost? Straightforward. Can we manage the cost so that we make a profit? Okay. Last but not least is still very challenging today. Industry 4.0 will come in to really emphasize and help on the flexible. Can we change with the demand? We have to be very adaptive. We have to be very responsive to the customer needs and the changing dynamic market. Okay, let's look at what is Lean. Lean is actually a very systematic framework or approach or even a philosophy to eliminate the waste. If you Google and look at this thing, there are 8 wastes that Lean say that we have to look into that, and it's possible to continue eliminate the waste. That's why they emphasize perfection, continuous improvement. There's no end for that. Okay, so one of the waste in the eliminate of the waste is overproduction. So we don't produce something that customer to want to, just produce just enough, whatever. Or before customer want it, or how much the customer need. And then materials, no waiting time for materials, people, machine, and so forth. And the movement, the logistic movement, or within the shop floor, the WLP movement for work center should be synchronized. There's the flow must be there. And do not create too many unnecessary steps that doesn't add value to the customer or to the whole operation. And of course, inventory, every day we are trying to optimize the inventory, no excess inventory, and defective product QA. Okay, so Lean actually emphasizes a lot of values. So the 5 principles of this Lean is, the first 2 is very interesting that I love it a lot because the first step of the 5 principles, the first step is define the values. You see, a lot of times I've been doing ERP for my whole life and all these things. And a lot of times we're just trying to look at the operation, sequence of operation, within order to cash, pay, purchase to pay, these processes. But we do all these things when we enable this, and then we put into the ERP system, then we look for ROI, we look for value. But in Lean, processes, you define the value. The value that the customer looking for, or the value your stakeholder within your company, right? So define the value, identify the value. Then only you, step two, then only you define the sequence of operation. So your sequence of operation, whether order to cash, procure to pay, forecast to deliver, is all depending on the value you identify. So we call it map value stream. So it's a sequence of operation. It all contains embedded the value. And then you create a flow. You see, sequence of operation, the flow is different. The flow means it's flowing very nicely, just a river, flow nicely. Okay. So then it actually do just in time, the pull system, and then always for perfection. So it's a culture and cultivate our culture for continuous improvement. People must get involved. So Lean has been proven to be very good in effective in reduce cost and improve quality. Okay, then what is smart manufacturing? Smart manufacturing is a synonym for Industry 4.0. In America, they call it smart manufacturing, IoT, before even German called it Industry 4.0. But nevertheless, smart manufacturing is to leverage all the advanced technology or digital technology to become smart. And using the technology like IoT, data analytics, AI has been very popular, and cloud, digital twin, robotics, 3D printer, data, or any blockchain. Okay, all these things is a technology that can actually help us to transform, become smart factory, smart processes. Okay, so that is digital-driven become a smart manufacturing. The second part that I like to really emphasize in the smart manufacturing is data-driven. Data is going to be the key, whatever we call it, currency or oil. Okay, so all the process is very important. Remember, just like I said, it's like process, people, and organization. So we need to actually develop a data-driven processes or data-driven decision making. You have to first collect data before you can even do AI. So the first thing we have been doing a lot is the real-time monitoring, like KPI, like the OEE. So to collect machine data automatically to do machine performance or even worker performance. From there, you can real-time monitoring your performance, tracking and all this. And all this OEE not only help you to track online, but it actually help you to do advanced scheduling. When you do shop floor scheduling, advanced scheduling, some of you may using SAP or the fair one. If you do not know the actual status of OUE, availability of machine percentage running is only 61.5, so you will not do a good scheduling. So and therefore, so radar monitoring, tracking. Then from there, we call a diagnostic root cause analysis. Then you move to predictive analytics. Predictive analytics will help us to do a lot of dynamic, responsive kind of capabilities. Okay, then that is a data-driven. Second area that I want to really share with you is the streamlined production. You have to have a streamlined production flow from receiving, from purchasing, place an order to your supplier for all the way to the floor. So this whole thing has to optimize. So when you look at the shop floor, so your spray painting in the injection molding or your automotive car assembly is manual. It's not optimized. It's not in the flow. So you need to streamline it. You need to, we call it streamline it by automating it. Nowadays, a lot of robots are doing spray painting, 100% robotic. So I call optimization of operation by using autonomous robotic AMR, 3D printer, whatever you have. Okay. So again, the whole process have to digitize when you're talking about smart manufacturing. A good example is like you implement MES, manufacturing execution system. Your production order is still paper flow. We need to digitize this. Okay, how the office telling or pass the what to do. Just check my time. What to do and what not to. What to do and what to produce today or tomorrow. So you need to be digitize the up floor and the shop floor. Then everything will be synchronized and digitized. Okay, next. Simulations and dynamic scheduling. When you come to this, the third area, you have a lot of predictive analytics. So from the visualization, diagnostic, predictive, then you move into predictive, you become very responsive. That is the ultimate goal of Industry 4.0. You have to be predictive first. So the more you think you predict, you still need human to make a decision. Human make decisions, then you make a decision. But when you come to the point that all your predicted things, it becomes so workable and so distinct, human no intervention. All pass it to computer to do that's called adaptive. So self-adaptive. So simple things to see. A good example would be changes of the order by customer straight away go down to the shop floor. You still need today a lot of us still need human intervention to say, hey, boleh, whatever this thing. But if you have a lot of this kind of thing happening, and then you predicting what to do and what to change, what to think about, what you want to set up time, and then when you come to ultimate Industry 4.0, we call it adaptive responsive, it do it automatically. But after you go through all these stages, okay. So this is smart manufacturing. So smart manufacturing is efficient. The flow is there. We are not talking about sequence operation. We're talking about flow. We're talking about managing the variation, then visibility. We use data, we can see what is going on for the entire supply chain. Predictable, and that's adaptive, which I just shared. Okay, when we put lean and smart manufacturing, do we see a synergy? Of course. We can use, just now we talk about lean, we use the value stream mapping, right? This identify value, then define a sequence of operation which value add that we can actually use these techniques to do that. Then only you know where is my bottleneck, where is my all these things, right? Where is the waste? Then we actually apply smart technology. Then the second one, data analytics. Vice versa, you can use data analytics to do a lot of collection. Because just like I've been doing ERP for a long time, then a lot of people say, we are not ready for ERP, but ERP actually, first thing is to standardize, not only optimize, standardize the operation, then only you see where is the problem. Okay? So same thing, we use technology, KPIs. If you are using Excel, but if you can use IoT sensor and this OEE, you can find out about that. So you have an insight into your process where then you apply lean technique to get the improvement. Okay. Demand driven, I talk about. Lean is demand driven. JIP improve is demand. Don't make more than what you need. Don't make before what you need. It can be very challenging. Okay. So anyway, so smart manufacturing is also talking about demand driven or this thing. So they synchronize. So visibility, we need to actually look at the whole entire flow. Okay, we need to manage the flow, manage the value operation, value added processes. We look at where you add value, where you don't add value, where's the waste, apply the technology. And then every employee has to get involved from the top down to the blue column. Get involved, continuous improvement. That's what Lean is encouraging, right? Continuous improvement, continuous learning. Okay, I think I better go. Okay, I think basically I'm done introducing smart manufacturing and Lean. Here, I just wanted to give an highlight about maturity readiness assessment is the way to kickstart the digital transformation. Okay, today I think the topic or the event is based on this thing. So usually this transformation or this framework, assessment framework, consists of 3 dimensions, 3 pillars: process, technology, and organization of people. So today I've already talk a little bit about process and talk a little bit about lean. How can lean synergy with process to help you to actually do kickstart to assess this thing. But before you do this kind of assessment, I think it's always good to have some awareness. We're not talking about solid technical training on robot and IoT. No, you have to know, especially if you're a top manager, what is Industry 4.0, what is digital transformation, how to do these things. Awareness training. And then another thing, when you do assessment, we need to know the framework or the methodology will tell you what level are you at, the current level, what's your target. We're not talking a high level, we're talking drill down into very, very specific questions. I just want to quick show you what I have here. Okay, so for example, process, then you go down into sub-dimension. You look at the whole process. End-to-end process, you start out with product development. You will have product development. You talk about product life cycle, which is also part of the process. Then you go down into operation. So you do procurement, MRP, procurement, you do planning, production planning, manufacturing operation, how you manage operation, and so forth. Okay, all the way. Then you talk about vertical integration. Vertical integration means how we actually integrate, let's say, the shop floor into the upper floor to do some control of the same mirror function. The good example like OEE, then or the supply chain, horizontal, this thing. So you need to actually understand your existing level. I'll just give an example, a quick example of these topics. This is going down into very detailed topics on processes. For example, there's a topic called production planning and scheduling. So assessment were actually based on this topic, this processes topic, and ask you what do you think is your existing level? Is it level 1, which is 100% human effort? Level 2, very basic computerization or digitalization. Level 3, you come to level 3 will be not only digitalized, to some extent we're integrated with other systems of this production planning scheduling. Then when you come to level 4, you have very effective use of data and analytics. Okay? Then number 5 is what I say, very attentive. Just quick run of this thing. How will you rate the degree of digitalization of this production planning and scheduling? Please consider the factors such as demand forecasting, production planning, scheduling, real-time monitoring, and integration within the system or with other systems. So you say, okay, level 1, we mostly human labor. That means you're using Excel to us is still manual, okay? Still use manual and this thing. Then you are level 2, maybe you use some kind of SAP, maybe SAP scheduling, that kind of this thing. Okay. But we are still not collecting data like we do a lot of data analytics, help you to do diagnostic and find the root cause of analytics. Okay, maybe to that some extent you do that. So maybe you're 2.5. When you come to 3, for this particular topic, production planning and scheduling, you actually using a very, very integrated or very helpful, no human intervention to do the production planning and so forth. Same thing, a quick one. Okay, so you maybe start saying that, oh, my existing level is number 2. We use some kind of planning or scheduling for a small ERP system or whatever, but we don't really analyze a lot of data. I mean, we still don't do IoT and sensor. So, but we want to move. What's your target? We want to move into level 3. Level 3 is that we want to apply digitized, interconnected, and everything with data analytics and diagnostic is coming in. Okay, So let's quickly look at another area, shop floor automation. Shop floor automation, usually in the assessment, there's one dimension, we call it automation, and then we look at shop floor, we look at enterprise. So this for look at shop floor. How automated is your shop floor? That means your machine, your production system. Is it automated or still using machine to run it, everything? So maybe you are level 1, so our shop floor is very heavily on manual labor for production. Maybe we use some kind of PLC to control, to set up the process, okay? And then we don't collect data. So we want to move into level 3. Straight away, you say, okay, I think we can do it with the investment, understanding the ROI, understanding the capability, we can move to level 3. Level 3 means straight away you go to automation of the shop floor. That means whether you use robotic, material handling, AMR, and collect data and so forth. Okay, so let me sum up with this. So again, we know each topic, each detailed process, we know the current, and we know the target. From there, you can find out a lot. The consultant will be able to identify the pain point, the gap from what level you are talking about the song to level 3, the gap, and the real improvement. Because you need to know the areas in improvement to actually prioritize what project we need to do. Quick win, a low-hanging fruit. On the right-hand side, we have the analysis report. So what we do is actually we come out a report and also we do a presentation to the CEO level, and we have a roadmap from the gap for the area improvement. We're able to identify the quick win and deliver project because of prioritization. There's so much things need to do. So we need to prioritize and we need to, and also ROI. Because a lot of automation in Malaysia, we find that they never go for robotic because ROI. So let's look at, but ROI is another topic. It's how ROI is actually quantify benefit divided by cost. The cost is very easy, but the quantified benefit is very challenging. So if you think out of the box, you can talk about more these things, your ROI will be better. Just a discussion. Okay, align with your staff is very important, training and change management. Because whether you want to study small or whatever you want to do it, this skill. Okay, so with that, I will end up here and thank you for listening. Okay.
Thank you, Mr. Ricky, for the enlightening presentations. Next, I invite Mr. Usman Sarwar as an engineering execution lead chief engineer and solution architect in Intel Microelectronics Sdn Bhd to join us on stage to share his expertise with us. Mr. Usman is a seasoned technical leader with 22 years of diverse experience in software, system engineering, solution architecture, and R&D across startups, government R&D SMEs, and multinational companies in over 10 countries. His expertise includes designing and deploying IoT, AI, edge compute, and cloud solutions for smart city buildings and manufacturing. Currently, as engineering execution lead and solution architect at Intel, he's focused on agile phase external with time-sensitive networking (TSN) for deterministic communications. He has a track record of successful projects like the Monash Smart City pilot and contribution to IoT standards with 25 patents and numerous international publications. He is a sought-after speaker and panelist at global conference. Let's give a warm round of applause to welcome Mr. Usman.
Good morning, everyone. Thank you very much for having me here. Are you able to hear me clearly? Yeah. Thanks.
First of all, again, thank you very much for having me here. My name is Usman, and I'm as thanks to the MC to introduce myself. I'm actually part of the Intel, which has multiple groups, multiple companies within it. I was part of the IoT group previously, and now I'm part of the FPGA business, where I'm primarily focusing on the embedded business, looking at industrial applications. So today we're just going to look at a holistic view of different technologies, how they are standing, and looking at from the point of view of smart manufacturing, how are we ready to implement or not? Looking at the technologies which are enabling Industrial Revolution 4 consist of several key elements, starting with IoT, big data, cybersecurity, artificial intelligence, blockchain, edge computing, cloud platform, and so on and so forth. Looking at the IoT side of the picture, if you really go into the detail of IoT, you can see that it's actually a very complex landscape. It consists of wireless technologies, wired technologies, uh, hundreds of sensors which are incorporated with the computational technologies and different type of communication technologies which are involved with IoT. I'm not going to go into a lot more detail about how IoT looks like, but my assumption here is that most of the people here, they have some understanding about IoT, how IoT looks like, and how IoT works. In order for us to enable Industrial Revolution 4, big data is one of the key elements. And in order to achieve the big data, or in order to achieve the data itself, the key element here is the IoT, because IoT enables us to get the last mile, last source data, which was not possible previously, when we're talking about 20, 30 years ago. And in order for us to deploy successful technology, it has to be incorporated with the cybersecurity. If the cybersecurity is not part of it, it's actually not practical to deploy it. Uh, you might have seen some of the examples in recent time, such as in a Nordic region, there were one factory which was decommissioned for a while because they deploy all the new technologies, IoT and stuff like that, and somebody hacked it. And after hacking, they asked for $2 million for again letting them use the system. So what they did, rather than they gave $2 million, they start asking people which were doing the manual work in the past, ask them to come back and start doing manual work for factory floor. So again, the key lesson was, even though we can deploy IoT, we can deploy state-of-the-art technologies, but if we do not put cybersecurity as main ingredient, it won't work. And it's the same thing happened. I mean, if you just search on Google, you can find out utility companies like Tenaga. They also have control network also being hacked. There are so many examples nowadays. Artificial intelligence is again another key element, but if you look at the core reason to use AI would be again looking at automation or making decisions which are more optimal. There are again lots of stuff going on. I will touch some factor of AI in my presentation. Blockchain, again, another very key element. And in recent time, edge computing devices have become quite a good reason to use it. One of the key reasons is because of the low latency applications. Like back in 10 years ago, people were talking about IoT, gateway, and cloud. Everybody looking at the same pattern. But when we start deploying it, what we found that some applications require a low latency, which could be less than 100 microsecond, less than 100 millisecond to, let's say, microsecond range, which is very difficult to achieve using cloud infrastructure. Then there are some privacy concerns using cloud computing infrastructure solutions as well. I can share some example of cloud computing which I use with this project. Now, um, interesting thing about enabling industrial solutions, we also have to look at the requirement that customers are asking for. Now, generally speaking, when we talk about, personal computers or servers, that's in two segments where there are, certain number of customers. As an example, we know about Dell, we know about Acer, we know about Asus. You look at it all top tier companies, then we can easily count them on your fingers. And then when you look at tier two, tier three, it's not going to be more than 50 easily. But when you're looking at industrial solutions, it's a very different game because there are a lot of segments and a lot of companies which are involved. Some companies are very small, as 10 to 20 people. Some companies are very big, which are thousands of people, like Siemens. Now, why I mentioned here broad customer requirement, because if you look at the different type of factories, if you look at different type of manufacturing processes, there are so many devices which are involved, and all of them, they have a different set of requirements. So, like in some cases, a customer or a computing solution which need to be deployed must have a time synchronization range of 20 nanoseconds. In another case, it could be 100 microseconds. So it varies. And based on those variables, there is going to be different type of solution which provide the customers. Long life support model means, like when we look at mobile phones, we look at PCs. Generally speaking, we buy around 2 to 5 years timeline. I mean, that's average. But when we deploy in a factory floor, it has to be in a factory floor for 20 years, 15 years, 10 years. So, the one key element there is to understand about the feasibility of it, the reliability of it, functional safety of those devices. Power consumption. In some cases, we deploy, devices which are enabled with battery powers. So again, we have to look at those devices which can operate over the long period of time. It may not be like when we use our mobile phones, 1 day, 2 days, finish. But in the case of some of the devices, they need to operate our battery for a long period of time. Secondly, the power also implies here about the heating element, because when you deploy a computing solution, which also generate much more power, much more heat, it also means that it may not last very long as well. Environmental conditions means when looking at the factory floor, looking at similar type of environment, there are circumstances where the temperature could be 120 degrees Celsius or 130 degrees Celsius or more. So in those type of scenarios, normal computation solution, normal software solution won't work. So there are a specialized way that we have to develop those solutions. In a case of personal computers as well as the server side, we know we have Windows, Linux, Mac. But on the industrial application side, it's a very different game because there are hundreds of operating systems. In some cases, they have variants of it. For example, looking at the FreeRTOS, you will see a lot of variants of FreeRTOS. We look at, as an example, different variants of Linux. And then imagine that if there are going to be a lot of different type of devices, and there are going to be different type of operating systems, we do need embedded software developers, which can write drivers for those devices to work on these specific operating systems. So there are definitely a lot of opportunities here. Strict bandwidth and latency requirement means most of the industrial applications require a bounded latency, and it has to be deterministic, not like in normal PC scenarios where in a PC case, it's the best effort. That's like part of the IT infrastructure. Whereas in the case of OT case, we have very strict requirements of running, robots, PLC, and so on and so forth. Just visualize for a second. Just visualize for a second that you have, like a proton factory. In a proton factory, you have different robots building a car. But just imagine if they are not synchronized, what will happen? They may not be able to produce a car. So there are certain very strict requirements here. Functional safety means that when a device works for a certain time or for certain operation, if something happens to the device, it should elegantly handle it. Just imagine, or let me ask you guys, How many of you have seen the blue screen of that on Windows? So in this case, we can't expect to have blue screen of that. Otherwise, just imagine the car is, some the robots are building a car, and in the middle of building the car, it may just fall apart. And lastly, cost effective. These devices, which are going to be deployed in hundreds of units, it has to be affordable for companies to deploy and support it. Another very interesting part here is that, in the case of, let's say, PCs, when you buy the PC, and I mean, as an example, if you want to upgrade the RAM, or if you want to upgrade a certain part of the PC, we know for 3 to 5 years' time, we can buy those parts, we can fit on it. But as I mentioned earlier, that industrial application need to be deployed for 10 to 20 years, which means the supply chain, the logistics also need to be in some type of a storage, or somebody have to support it. So it's a bit of complex landscape. Just giving a little bit of overview here. When we look at the computational landscape, we have GPUs, which are good for vector processing. Primarily, we've been using it for gaming in the past, but for the last a couple of years, it has been much more relevant for AI, deep learning, model trainings. Specifically, we have FPGAs, which are very good for spatial processing data. But the good thing about FPGA is that it is a low power, it is a high compute and low cost device. What it also means here, as compared to GPU and others, that there's a way for you to reprogram the circuit. So, like in the case of GPU, CPU, or ASICs, which I will explain later, FPGA has the flexibility that if you write an algorithm, you can build a circuit which will work very, very fast. ASICs are application specific ICs, low power but very high. They are high cost because you have to manufacture it specifically for certain application, and CPU general purpose that we mostly use. So in a nutshell, what I'm trying to say is that there are different type of compute solutions. Each compute solution is good for their own specific type of work. What's going on? Anyway. Connectivity landscape, I try to give an overall holistic view of the communication technologies, where on the most right, we have most simplest technologies like RFIDs and NFCs. Then we have different type of low power wireless personal area network technologies. Most of these technology are giving around 64 kilobits to 128 kilobits range. Then we have a low power wide area network technologies such as LoRaWAN, which generally mean again having a low computational power, having a low throughput, but you can reach 6 to 10 kilometers range depending on your landscape. And then we have a local area network technologies also used in factory floor, such as Ethernet. And Ethernet has been used with the industrial protocols, such as Profinet in the past. And then we have cellular protocols, 5G, 4G. Again, it's a very complex landscape, but I'm just trying to make it as simple as possible to understand the complexity here. I will try to focus primarily on the LAN, Ethernet, IEEE GSM side, because this is more relevant for IR4. Now I'm going to look at and explain a bit about the overall end-to-end solutions. End-to-end solutions consist of most left, you can see on the bottom is an IoT network, which consists of different type of devices, such as robots. It could be a PLC, it could be a sensor attached to an asset, and mostly they are under the category of embedded systems. Then on the middle side, we have a gateways. Different type of gateways are available, which can translate a protocol coming out from, as an example, legacy devices, but making it much more modern communication protocols. And lastly, on the right side is the cloud computing platforms, which I think most of us know from the context of AWS, Microsoft Azure, and some of the local cloud providers. But now let's look at the compute part of the story. So IoT network having there are different type of computing solutions there for IoT devices, such as most of the devices you can find in the market right now are ARM-based SoCs. And then another one which has captured quite fast is a RISC-V. A lot of RISC-V based solutions are coming into the market right now. And then there are some type of FPGA solutions like Max and Saturn 5, which also provide embedded and IoT applications. On the software side, for IoT side is as I mentioned before, there are multiple operating systems such as FreeRTOS, embedded Linux, Zephyr, and so on and so forth. So these type of computing solutions and computing solutions are used for product solutions such as sensors and actuators, PLCs, industrial robots, and so on and so forth. Now, looking at the central part of it, which is gateway, which is probably mid-performance computing solutions, we have again ARM-based SoCs. We have Atom-based. AMD also has their solutions. Xilinx has their solutions, and so forth. But in this case, we mostly have a operating system which is either Linux-based or Windows-based. So generally, there are products which are industrial PCs, primarily used in SCADA as an example, and also being used for video analytics. Lastly, on the cloud side of the picture, which is a very big market, we have a lot of solutions there. For example, I did mention about Gaudi. Gaudi is Intel a specialized SoC to use for training purposes, as what NVIDIA does with their GPUs. The major difference is the power to compute ratio and the cost itself. Then there are different type of FPGAs, such as from Xilinx and Intel. We have different type of CPU solutions from Xeons to, again, AMD has Xeon solutions. And from software point of view, there are again Linux, Windows, main operating systems, but providing different type of a cloud infrastructure using Azure, AWS, and Google. Now we're going to talk a little bit about standards and certifications, because if you don't have the standards, which also implies that it will be a style of business where everybody sells their own devices, and once they sell their own devices, which means they basically make people only confined to their own ecosystem, which is not healthy for the economy scale. So why we need standards and certification? Because we need to create an ecosystem for multi-vendor products. We also need to have interoperability of different vendor products of course, for achieving operational requirements. What it implies is that when you look at the factory floor, it should not have only one type of device installed in a factory, right? So there could be possibility of having a PLC from Siemens, then having a sensor from another technology company, and so on and so forth. All of them need to talk to each other. And the major trend which is ongoing right now is that most of the companies or most of the alliances are going toward the open standards, because that's the way to go. The picture here shows multiple millimeters. The reason is because all of them are running on different systems, so they can't integrate. So it's a very interesting type of environment here, example here. This is just to give a quick overview about the standard certification landscape. There are more standards available in the industrial application, but I'm just gonna just browse through here to tell you there are ISO standards, there are ISA standards, there is the IEC standards, there are IEEE standards, as well as IEC, ISO standard combined. I will talk a bit about the IEEE here after a couple of slides. This is the IEEE TSN standard landscape for industrial applications, and what it applies here is at the base we have a standard Ethernet, IEEE Ethernet, which has been in industry for many years. But on top of it, IEEE have defined a new set of standards which allows us to do a deterministic communication and time synchronization. What it means is, in the first case of time synchronization standards, we are able to do deterministically synchronization between computers with the latency range of master of the roughly 20 nanosecond range. So what it implies is that if you have a one PLC, you have another PLC, and you have a maybe master controller, there's a possibility for you to do synchronization between all the devices within the range of 20 to 50 nanosecond range. Secondly, is traffic shaping standards. What it implies here is that there is a possibility for us to let's say transmit a video traffic, and we can also have a IT traffic at the same time. For example, having a browsing or a low priority traffic, but we will be able to have a smooth flow. That 8021 QAV standards have been used in AVP industry for the last couple of years. So even though this is for industrial application, but it has been also adopted by AVP industry, audio video bridging industry. One of the key examples would be if you go to GS cinemas. I believe everybody have watched the movies, must have gone to concerts. If you look at all times, 20 years, 15 years ago, if you go to concerts, in the concert, if somebody sings a song, you might remember that from one speaker you may be hearing a different sound, and from another speaker you might be hearing a different sound. So those problems were solved using these QAV or AVB standards. Then we have a QBV standard, which what it does is we can tell the computing system to transmit at a certain time deterministically, which means we can tell every 32 microsecond range it should transmit a certain payload. Maybe it is for a PLC, maybe it is for another industrial application, but there is a way. Now, just to give a context to everyone, when we talk about 1 second, 1 second has 1000 milliseconds. 1 millisecond has 1000 microseconds, and 1 microsecond has 1000 nanoseconds. So I've been talking about the first standard is that we are able to do 20 nanosecond range synchronization between two machines, which is at the billions of seconds range. And similarly with the microsecond range, which means that it's a very small unit. And this is part of our work which I'm doing in Intel right now with the next generation SoCs, where we are building these solutions which can enable IR4 or next generation industrial applications. And one of the key factors here is you can notice on the top, Profinet, EtherCAT, RS485, all of these standards, which are part of the legacy, will be using or converging to Ethernet. Because it's a cheaper technology, it's a well-defined and well-used technologies. And on the top of it, you can see there are multiple certifications which are coming in and providing certification for industrial applications. This is just to give a glimpse from some of what we did. On the right side, the black picture, it represents the master clock offset. What it implies is, all of these small ranges, this is the deviation within the range of plus minus 20 nanoseconds. Plus or minus 20 nanoseconds. And these pictures reflect that the blue line reflects a AVP traffic sending 8,000 packets consistently. But red line reflects here the noise traffic. So even though we introduce the noise traffic, it doesn't affect the actual high priority traffic. So this is just to give a glimpse at a high level. Now, there are different global alliances which are enabling next generation industrial applications. It's a Profinet, Profibus, ODVA, Avenue, CLPA, OPC. But the key major trend which has happened in the last 2 to 3 years is the TIACC, which is an industrial automation conformance collaboration, which includes almost all of them together. So what it means is that eventually all of these alliances which are producing their own devices, there's a possibility of interoperability. That interoperability may happen only on the application layer, but it's actually a very good trend. Now, again, looking at industrial automation, I'm not sure you're aware of it, but on the right side is a high-level picture about how industrial network looks like, where we have a device level 0, 1, 2, 3, all the way to 5. And most of the field devices like PLCs are present here in this device level 0 to 2 level. And oops. And what I was trying to explain earlier about the conformance and interoperability was that, so let's say we have a different type of devices, and each device are configured to do a certain task at a certain time. So there will be a way for us to do a conformance in a control loop. Conformance in a control loop was having different type of devices. So what are the future trends for next generation solutions? First major trend is that there's the convergence of industrial PHY and protocols toward IEEE Ethernet with the TSN features. What it implies again is that having a base Ethernet PHY and base Ethernet NAC, there is a way now the Profit NAC, EtherCAT, they can visualize the standard Ethernet. Second one is edge computing integration for low latency AI inferencing. I have done this work before, back in Monash, University in Australia, where when we deployed different cameras, AI-based solutions, initially what we found was when we are deploying the model and we are looking at of identifying those actions, it was very slow, especially when we were deploying hundreds of cameras. So we did a deployment of hundreds of cameras with hundreds of edge computing systems, and we were able to demonstrate the low latency AI inferencing models. Third one is the workload segregation between cloud computing and edge. As I mentioned before, that previous trend was everybody was using cloud, IoT devices, and gateways. But moving forward, we can clearly see from the solution designers architecture point of view that there are certain use cases which can only be enabled on cloud. There are certain use cases which can only be enabled on the edge. So, there is a clear boundary there. Then another interesting point which is coming is for the last 2-3 years is the new business model for monetization of deep learning models. So those companies which are having a infrastructure of building and training models, and not everybody can afford it. I mean, let's face it, those GPUs are very expensive. Let's face it, those computing solutions are very, very expensive. We're talking about hundreds of millions of dollars investment. So now there are new business models coming in where they are selling they're selling as a service or selling as the models for people to incorporate into their inferencing solutions. Then we have majority of deep learning models for predictive analytics is another trend. So in the first case, we have enough data. The second case, there is a way we can train the data. And now, as we have enough data, there is a way for us to do predictive analytics. So there is a step-by-step procedure here. And lastly, generative AI is making a very big change in every possible way that we can think right now. So it's not only going to be what we are doing with ChatGPT to get our questions and answers done, but it is going to play a quick and good role, important role in the factory floor where somebody asks that system to tell what are the optimization which are required, and generative AI could able to help in finding out and fixing those problems. So what are the implementation deployment challenges? The first biggest challenge is the scaling up of IoT technology without proper security. As I mentioned before, that there are vulnerabilities. We need people, a security expert, not only on IT side, but also on the OT side. So if they have a good understanding about how those systems are going to be deployed, there's a possibility that we can fix this problem. Second one is implementation of standards. Even though we got these new standards, but we still need companies to adopt it and implement it, so eventually they can do interoperability. Thirdly is a slow adoption. Uh, the industrial applications, as I mentioned before, the cycle time is around 10 to 20 years. So and that's why some of the companies are not really pushed. So there are the key push factor would be, I think, government and the new business models. Heterogeneous, massive, unstructured and structured data management. This is a very big problem. We do talk about having a lot of data, but once we get the data to refine the data and to work with the data is a very big challenge. I personally have seen it in a couple of projects. It requires a lot more time than most of the people anticipate. Implementing efficiency, prediction, personalization, safety is very complicated. So we do talk about these words when we talk about AI solutions, but once you have those data, once you look at the data to work with, it's not easy. It actually takes, from a practical solution point of view, it takes a while to sort it out. I personally have seen a couple of projects which I've worked with in Intel and outside Intel, and it does take a lot longer time to sort it out than what we anticipate. Uh, Another challenge is the adoption of implementing strategy for migration from legacy systems. So those people, those companies which are already running legacy devices, as you know, that they won't like to touch the running system. I believe most of the consultants which are working with factories and manufacturing, they know that it is very challenging to convince them to move away until it is being pushed by someone. And skill shortage is another problem. We have a lot of work to do, but we have challenges of people which know how to work it. Lastly, I didn't mention it here, but another important point is the mind shift. We need to have a change of mindset in order for us to jump into IR4 and solving the problem. If we bring our baggage, order baggage with us, what we have done previously with what we are doing with IR4, we will also bring forward our previous challenges and problems with it. So the mindset is also very important. So I'm just going to go very fast because of time. This is one of the projects which Intel did with BMW. And the key thing which they achieved was the AI as a general purpose tool. What it means is the customer was having a goal of how to use AI inferencing as a non-solution system, a tool, not only for data scientists, but they want to scale it for anyone to use it in their company. Just imagine 30, 40 years ago, there were specialized people which were trained to do Excels or sheets. There were specialized people which was trained to do application like word processors. But then eventually it became much more usable by anyone. So the new trend has studied where companies want their employees to use AI just like a tool, just like a word Excel in the future. So there are multiple things which have been done. I'm just going to give you a little bit of example here. In the case of BMW, Robotron, and Intel, we have created the AI APIs and tools, and we've been using open Vino solution where they are able to they are able to conform to General Data Protection Regulation, which is a GDPR. You can see the picture. Okay, this is an actual picture, but then because of privacy laws in Europe, so these people are going to be all darkened. But they can get a post estimation about what people are doing. I will skip this second one, even though it looks cool with the water bike because of time. But the key point here is that scalability of using um, the solution of the edge. Other key case studies, which I will just quickly go through, will be worker safety, which is done by Caterpillar. They have installed sensors, especially the cameras in the helmet, and then they are able to identify by scanning and assessing the working condition and if they are safe for the workers in that area. Quality control, this is being used by manufacturers these days now, where they use the way of getting the heat sensors imaging of motherboards and then they can use AI-based solutions which are being trained earlier with the base reference model as compared to the one which will not work, which may have issues. So that it will help to do quality control in automated manner. Lastly, remote monitoring of manufacturing operations. There's a company called Armal, also working Intel. They do again, there are certain things they're doing with industrial IoT software for production and process. I'm going to conclude my presentation here by saying that we have discussed about overall compute landscape, communication landscape, and end-to-end solution landscape. And we also discussed a couple of case studies to tell what AI, direction of AI is going into industrial applications. Now, are we there to implement IR4 solution? I will confidently say that yes, we do have computational technology, we have software solutions, we have all the major ingredients. It's just a matter of time to build those applications. Here at the bottom, I'm trying to show a very interesting picture about one of the worst traffic jam. I mean, we know we talk about Penang Bridge traffic jam or KL traffic jam, but I think the worst one is in Hong Kong, Macau. This is the 50-lane highway. It's basically Beijing, Hong Kong, Macau Express, 50-lane converging to 20-lane. So my point, what I'm trying to say, it is a complex landscape right now. When we look at standards, when we look at different computation technology, softwares, everything else. But eventually, I think, as we have always done as humans, we'll again put it in a way that it is simplified and visible. So the complex problem of 50 lanes can be sorted on 20 lanes eventually for us. And I believe it will be very soon. So just to wrap it up, what is our readiness? These are pictures which I have taken from embedded world in Germany a couple of years ago. These are the, again, industrial PLCs and sensors and I mentioned before about EtherCAD, Profinet, using TSN, but these are only being done. These are only being done in Germany, in the US. And this is a very interesting picture because all of these devices, so starting point all the way using the, daisy chain network, it can achieve from end to end within 32 microsecond range. So when it goes from this device all the way to a last device, the communication message can achieve or can reach into 32 microseconds, which is very cool. So again, thank you very much for having me here and giving me a chance to present about my doing. Thanks.
All right, thank you, Mr. Usman, for that presentation. Next, I invite T.S. Martins, Stephen Muller, Principal Consultant at Excellent Profits Sdn Bhd, to join us online in the Microsoft team as he is unable to attend our session physically. Throughout his career, T.S. Martin has added numerous companies across diverse industries in developing products, services, and business models to foster organization growth. With over 20 years of experience, he has spearheaded the development of more than 20 products from inception, resulting in 2 field patrons. As a speaker, trainer, and consultant, he has engaged with thousands of participants, sharing his expertise on Industry 4.0. His extensive experience in Europe and Asia led him to several meetings and FMM in designing roadmaps and strategy for technology implementation and training in Malaysia. T.S. Martin's passion for innovation and knowledge sharing is evident in his focus areas, including manufacturing 4.0, digital leadership 4.0, industry 4.0 readiness, digital Lean Six Sigma, and digital design thinking. Let's give a warm round of applause to welcome T.S. Martin.
Thank you very much. First of all, I want to check, can you all hear me? Can I get a quick response if the audience can hear me?
moment that's Martin, we can hear you, but it's quite low, so allow us for the technical issue.
Okay, no problem.
Yes, Martin, can we try again?
Yeah, can you hear me now? Is it good?
It's already the lesson.
Can you hear me now? Is it okay?
Not yet.
Not yet. Okay.
Not yet. Can we have you to try to speak again?
Yeah, sure. Can you hear me now?
Yes. Yeah, we're trying to. Not yet.
Okay.
Cepat. Okay, can we have you try again?
Yeah, sure. Is it better now?
No. Yeah, we try to get the mic, but it's still low.
Okay, is it get better now? Can you all hear me?
Still not yet. Let me try again.
While doing the technical things, if anyone wants to go for toilet break or bio break, so we can able to join after 3 months.
Sharing this check this. Understood? Thank you. Yeah, got it right already. This one we already shared. Yeah, but this one is sharing through HDMI. Okay, I need to go to setting first.
No, you don't need to.
No, the here for this one, so I need to go for that one. And this one. Can we try? Yes. Which one? This is just the correct setting. Okay. Yeah.
Yes.
There's a mic problem. Martin, can you speak?
Yeah, I can speak. Is it okay now?
Can you speak now again?
Yeah, I can speak. Is it okay now? Can you hear me?
Yes, I can hear you, but there's some sound problem. We are rectifying it. Just give us a minute.
Yeah, sure. No problem.
Can you speak now?
Yes, I can speak. Is it okay now?
Yes, it's good. It's good. Good to go.
Okay. All right. So then we wait till they are back from the bio break, and then we can start.
Okay. Thank you.
Thank you. No problem. So then I'm testing my share screen. Can you see my screen?
Yes, we can see your screen, Mr.
Okay.
Martin.
Very good. So then we are all set. So once you say that we can start, I will start.
All right, let's wait for our participants to fill in the
Yeah, sure.
agenda.
Yeah.
So just for your information, Mr. Martin, we can see your slide and we can see you as well.
Okay,
So,
fantastic. And you can hear me.
Nice. Finally,
So
thank you very much for the wait.
All good.
Are you able to see our room currently?
Yes, I can see that the people are coming in. Yeah.
Okay, all right, that's great.
Okay, Martin, you can start.
Okay. All right. Very good. Thank you. So good morning, everyone. Assalamualaikum. Thank you for having me here. My name is Martin Stefan Mullet bin Abdullah. So thank you very much for this arrangement from Datalytic.ai side, especially Dr. Imran, that we have this session today. Yeah, I wish first of all I would be in Penang also, but due to my schedule, I have a few other sessions this afternoon, so I could not make it to Penang. I will miss my iftar in Penang with the fantastic Penangan food, so that one is a miss, but due to my other arrangements, I could not make it. I hope so in the future that I can come to Penang and see you all in person, and then we have another session maybe in the future. So that would be something I would like to do. So thank you very much. And my topic today is fostering a culture of innovation and collaboration. So as you heard a bit about my background, I am doing innovation R&D since many, many years, and it is really an area where I'm passionate about, besides sharing and training. And I would like to share you a few things in the next 25 minutes about how you can embrace innovation, collaboration, and actually what are the challenges ahead of that in changing times, in changing requirements, in changing skills. So all is that what we are talking now from my previous speakers, and I believe the next speakers following me, they will also talk about this change of mindset, change of how we work and collaborate actually all together. So first of all, I want to show you a little bit about the top skills in 2023. So that was last year. And you can see that is what I'm preaching from my side, from my company especially as well. We can directly see a shift over the last few years to more cognitive skills, as you can see that. And also some points, because as a training provider, as a consultant, we also need to understand that we need to have a certain curiosity and lifelong learning. So having this said, we can see here analytical skills is the #1 ranking in 2023, followed by creative thinking. These are both called cognitive skills. So in Industry 4.0, we're moving actually away from more or less hand skills or workmanship skills due to the fact of automation, digitization. We are moving more towards cognitive skills. So this is one message I want to send across why innovation is so important. And the other one, as I said, the self-efficiency. So the part of being curious, doing a lifelong learning. So we all need to implement that. We never stop learning. That is one of the crucial elements that we need to consider. So this was in the top 10 skills in 2023, based on the World Economic Forum. Now, fast forward, 2024 has arrived already. So this morning, I realized we already passed the first quarter. So first quarter already settled, cannot do anything anymore. Now we need to have the remaining three-fourths of the year to adapt and maybe do some changes in our work and to keep our business running. So what has changed in 2024 to 2027? So here are a few pointers. I don't want to go too much on the technology part here. We heard this just now from Mr. Sabar, that we have AI and big data, and I think we will talk more about this later as well. And also technology literacy has moved up. So I think this is pretty good in terms of the recent development where we see with generative AI. But my focus again is on the cognitive skills and innovation skills. And I want to highlight a few of these which have been moved up. So first of all, creative thinking has become the #1 skill. As before it was analytical thinking, now it's creative thinking. So that means we need to put a high emphasis on how we become actually creative and how we can actually innovate. So it's the #1 top skills. Curiosity and lifelong learning has also moved up behind the technology literacy. But what I want to emphasize here as well is system thinking. So this is a big part of innovation, system thinking. And what has newly been introduced here, besides some others that you can see, is talent management. So putting these components together in terms of skills arising and in terms of how we can foster innovation and collaboration in our organization, we need to understand that there is more cognitive skills required. Skills that have not been so critical before, like creative thinking and now systems thinking, which I believe since many, many years there are a lot of theories in Germany written, which I read before, which is very interesting. So system approach and also how we manage talent. So we hear this very often when we go out there as consultant, the new workforce, the new generation. So all this is part of actually an innovation process and how we actually go about innovation in general. Now, I have 4 pillars of innovation that I would share with you. First is collaboration. So there is no innovation without collaboration. That is the first big message I want to send across. The times are gone that you have this great genius sitting in their laboratory and doing something. So this is not there anymore. So collaboration is essential. Ideation, that's meaning how we generate ideas, how we come to fast learning cycles. I call this purposely learning cycle because they're iterative. Implementation is a very big challenge for many companies. I have been recently talked a lot to big companies in Malaysia also. They're talking now about how can we be more innovative? How can we create innovation and making this a strategic point? And of course, value creation. So there is no way you can innovate without creating value. So you must create value at the end for yourself, the company, as well as your customer. And furthermore, we come later to this, to the society actually. Now let's go these 4 pillars one by one. So collaboration is a big topic, and in innovation, as I said this just now, it is not about one single person sitting in a room, developing something, is a genius, do something by his own. It cannot be done like that. Now, collaboration is very important for innovation-friendly culture, and it should be emphasized on that. So what is the main point here? As we said this just now, curiosity. I'm still eager to learn every day something new. I'm still eager to find out something. So we need to encourage our staff to equally take some risk. But I come later to that, controlled risk. So, and also foster a point of experimentation, figuring something out. So I believe many have heard about design thinking as a tool, which is very good. And design thinking is a non-linear process. So here, example, for my team, we always, or often, not always, but often start with an experiment rather than we go through a stringent list of system requirements. What does the experiment mean? Clients usually don't really know what they need and what they want. So therefore, we need to give them actually a few options before we actually get the details out. So experimentation here and curiosity means really to find something and encourage this in the staff, in the employees, to search for something new. Now, when we see, for example, NVIDIA has presented their latest technology, and I remember the statement from Jensen Huang. He said, the matching of the 2 dies, I'm not an expert in that field, but the matching of these 2 dies for his new chip was physically not thought about that this can be done. But the engineers figured it out, how we do this. I saw this video, very inspiring. So this is meaning what we mean of curiosity. Going to that point where we say a physically or logically or maybe based on historical experience, it cannot be done. So this mindset of finding other solutions, playing around, trying things out, trial and error, is a very important part in the culture. And furthermore, what is a lot of challenge for companies is actually cross-functional collaboration. So I do a lot of design thinking workshops in the industry, and I always encourage the company to give me people from every department. Even though it's a technical challenge, it doesn't matter, because we need to see that actually the points of view from other departments as well. So this will help us inspire to get actually new ideas, new solutions maybe, because when only engineers solve this problem, we forget about the purchasing department, we forget about the production department, the marketing, the sales and all, because engineers, we are only focused on solving the problem from a technical point of view. So this kind of innovation will not lead to very good market products. So my previous work, I always focus on that, and I want to companies to do that, or organizations to do this as well, to have cross-departmental collaboration to get actually this different point of views. Now, the other effect is they're working together, they collaborate on a project, maybe on a certain task. In the long run, it will enhance the whole collaboration within the organization as well. So the communication is better, they get to know each other better, and this will help in the long run as well. And of course, this is a very critical point, provide time to be creative. Now, many companies or organizations, I'm dealing just with a few of them, also from educational sector, they want to be innovative, but they have so many tasks to do on a routine job. So you cannot expect that employees maybe be creative at home. They have their family, they have their friends, they have their work-life balance, so to say. So we need to create room where they can be creative. So my rule of thumb that I give last time to organization, and that is what you all need to think about, that is only my rule of thumb. You need to allocate a certain time, maybe 2 hours per week, maybe 20 hours per month, I don't know. Yeah, so there's different rules. I usually use 10-15% in the past for my team to be really creative by themselves. So they get tasks and they work on that independently. And I give them the freedom to slot this in as and how it goes during their days. Also for engineers, it is possible. For production, might be a little bit challenging. You need to be organized. However, there should be some time and some room given to them where they can be creative. It's a very important point. Now, the other thing is risk-taking and learning from failure. So we all need to learn to embrace failure. Failure is a very good thing. That is something that is a learning of opportunities. So technical failure, as long as they are not costly, is good. No? So that is a fine thing. You need to embrace a phrase, and I think I know Asaha is also there. We mentioned this a few times. I remember this when I was in PSDC many years ago. If you fail fast and fail cheap. Don't fail expensive. Huh? So encouragement means here, fail fast and fail cheap. What does it mean? Today, when we do some testing, some experimentation, we have the luxury not to go for machining parts anymore. We can use 3D printing. It's relatively affordable. We can use other methods. We have cheap components like Arduino, Raspberry Pi. All this is very affordable and we can do a lot of experimentation there. So it's not necessary that you were seeing just now that you need to buy a PLC high-end grade to actually test certain things out, to be innovative. So provide these tools that are affordable, that are easy to use, and then be creative and fail fast and fail cheap. So very important. So a very important point here is also fail is not a verb. So most of us think fail is a verb. That is not true. Fail is actually only an acronym. There is no verb fail. There is only an acronym. And fail means actually first attempt in learning. So failure is something very good. So when you walk out today of this seminar, remember fail is not a verb. Fail is an acronym. And you should encourage fail fast and fail cheap in your organization by providing an environment that let people explore and experiment in that sense. Now, the next point is ideation. As you can see here, I put a picture there that is typically how ideation thought of is happening, but we come a little bit more into that. So first of all, ideation cannot be without a process. No? It must be part in the innovation process that you have. So we need to identify how is actually your innovation organized. You cannot just say, okay, I want to be innovative. That's what many people believe it will work. But there is no process. There is no governance. There is no framework. So people get lost. That is not, oh, okay, come, let's meet for 20 minutes over lunch and be creative. It's not working like that. It can, it is good, it is nice. I also do this before. Lunch is a good time to brainstorm anyhow. Over food, over drinks, the brain is more relaxed. But there must be a process there. So if you just start ideation without a proper process, without a proper guidance, in my eyes, is a waste of time. So if you just say, okay, let's come meet today, you must be creative now, it will not work in my eyes. And all ideation that you create should focus on the people. So it must be what we call human-centric. So every product that we lead out, every product that we want to do, every process that you want to improve inside your organization should be supporting humans, should be human-centric. Technology, as Ricky mentioned, for example, ERP and all the guidance that you have, all the processes that you need, should be help human to accelerate. So when we ideate, for example, for a best process improvement, we should still focus on the people itself first. And very important, ideation is an iterative process. It is not necessarily that when you have one session, you finish it and you have the best solution. Usually you need a few rounds, because when you have an ideation process or ideation session, the brain just started to think about the solution. It is a starting point. It is not a final destination point. So it's very important here also to give room that people can iterate and actually fine-tune over a certain time frame, not too long, but at least for a little bit of time given, that actually you can think, digest, and reiterate the solution that you propose. So first of all, we need the right process. I have developed one process from my side. It's a very short process. It takes only 1 hour, maybe 90 minutes, if we need a bit complex topic. So we use a process that actually help us to come from ideas to concepts. That's very important in my eyes, that we can actually create clear ideas, clear concepts after a short period of time. So the process that you use is very, very essential to make ideation not a waste. I have said I've been in R&D very long, and I didn't like all these times when I sit one day in a room and at the end of the day, nothing came out. It's just a waste of time. Here I created this process which we can have actually 60 to 90 minutes to create really conceptualized ideas or conceptualized solutions to evaluate and go further from there. And of course, use the right tools. So a bit challenging sometimes to others. I don't use paper anymore. I don't think it is the right tool in our world. We cannot, I say this many times, we cannot teach Industry 4.0 and digitization by using pencil and paper. That doesn't work for me. It might be helpful, but today we have wonderful tools, digital platforms for brainstorming with sticky notes, with analysis and whatnot. And here I give you an example of this process that I usually use. And you can see there is an ideation session, and then we fine-tune towards actually the outcome. And this is done within 60 to 90 minutes. So the tool is very important, because when it is digitized, everyone can access, everyone can add on, everyone can play around whenever they are free. So there's not necessarily the constraint of having physically the people together. This is one big advantage. So right process, right tools, very essential for ideation. Implementation is important as well. So how do we implement these processes? So you must have a structured management of ideas, that's first. And you also must have a structured management of the innovation process itself. This one is a little bit technical. This is individual also, depending from company to company. And you must have allocated necessary resources to establish the clear roles and responsibilities. So because this is very independent on companies, I just give you a rough framework for that. So what are the two major processes? The first process should be idea management. So idea management has become very much focused in the last 5 to 6 years from big organizations. There is software now for that, who help to do innovation or idea management. So idea management is mainly on giving feedback to the respective person or to the respective group where the idea is sitting at the moment. So that has not done anything with innovation yet. However, every idea in a company should be captured at any point of time. And you see there's two entrances here. One entrance is the open ideation. That means I just write an idea. And one is a strategic idea development. That means we have a workshop particular on one topic. So both feeding actually this process of idea management. The other area is actually the innovation management process. So we have typically 5 stages as a generic process. However, again, we need to customize this to companies to give an ideal, typically innovation process for your organization. In general, these stages here in between can reach between 5 to 15 or even 20. It really depends on your organization. However, they all are sub-stages from these 5 main elements. So this is what typically we need to consider for innovation. Again, here we need to differentiate one more level. We have 3 levels. We have actually the process of managing ideas and innovation. We need to talk about methodologies in our organization. So that is different methodologies. So for example, Lean Six Sigma, design thinking. And we need to talk about tools, tools that you can plug into these various methodologies depending on your need. And you can plug in these methodologies according to your organization and the need towards your session or towards your process. So there is a little bit of room also for creativity inside how you manage the process, the methodologies, and the tools. Last but not least, we need to talk about value creation. And today I put this picture here, the SDG goals, very important for all companies. We need to identify our goals here. So it's not that you just create something new. So value creation means you must be value in terms of economic, because we all need to grow, we need to make money. That is the purpose of every business. But there's also value for society. There's value for the environment, how we protect the environment. We all have the challenges ahead. I'm very happy that we see developments now, especially for EV cars or for battery technology in general, going from lithium to salt or to other elements which are more easy and environmental friendly. And of course, customer satisfaction. You all have customers that you need to satisfy so that you can grow your business. So align your goals in terms of innovation towards SDG, how you want to support one or few of these categories. That gives you an identity in my eyes. It's very good, it's very helpful. I have done this for my organization as well, which gives us a clear focus what we want to develop, why we are here, and what we are working in terms of innovation, in terms of creativity towards our clients. And then you should measure, of course, there should be some key performance indicator to monitor your innovation. So it's not just, as I said, you just try something out. Of course, there is different phases, but we need to measure that we are on the right value, on the right path. And all KPIs should create value in that sense for customer, company, and society. So there's not a KPI, for example, oh, we must file 20 patents. 20 patents does not mean anything. I can write a patent very easily. There's not a problem. Or last time my KPI was how many invention can you produce? So we had 2 inventions. So after 1 month, I finished. That's very, very easy, very settled. But it does not create any value for the company or for the society. And last but not least, you should also define KPIs for personal growth of your employees. So I had this KPI in all my employees that they have a personal growth, a competency level growth, where actually they need to fulfill as part of their innovative work that they do. So this is a very important point for me, because if employees see not a KPI that is rated to them in personal growth, it's very hard to inspire them and give them time. But when we have this, I feel they're more engaged, they're more excited about innovation because they see it is a part of their assessment as well, and they want to achieve a good assessment. So it's a very, not a sentimental point for me, but a very important point for me that actually we have this kind of arrangement. So last but not least, this is my last slide for this session. Very important in terms of innovation is to build an innovation ecosystem. An innovation ecosystem needs to be done in my aspect because you cannot innovate alone. So you have not all the experience, you have not all the maybe facilities, the know-how, the equipment, the resources financially maybe. So see that you can build an innovation ecosystem in the long run so that you can collaborate with customers, with suppliers, with universities or with research institutes. We have a lot of partners. I myself, we have a lot of partners there where I do innovation together. Sometimes I bring them ideas. I have a young startup. They're sitting beside me in my office. They have the office next to me. And we work on AR, VR, for example. So I brought them new ideas. We applied grant together. We developed the product. So that is what it means, because they're the expert, but maybe I have the use case. I have the real need in the industry, or I have the application at the end where this technology can be used maybe in a new, in an innovative way. So go out and work with this stakeholders together. It's great to see that you are today in a university department. Usains is also there. So work together with them. I feel always this is a little bit missing in Malaysia. In Germany, this is very active. The academic and industrial collaboration is very strong. I always feel here is a little bit not so strong yet. I might be wrong. I cannot speak for all universities. However, what I see, I wish there would be more, and I hope we can have more together of that. And of course, creating networks, creating clusters is helping to foster innovation beyond your doors, beyond your organization, so that actually you can work more in detail, more collaborative together. So that's from my side. Thank you very much. And if you want, you can join me on LinkedIn. Thank you. I see you on the small screen down here. So thank you very much. I have to work here. Thank you.
All right. Thank you, T.S. Martin, for the enlightening presentation. Next, I invite T.S. Samsul Abdul Wahid, Director at MIMOS Ministry of Science, Technology and Innovation. T.S. Samsul is currently the Director of Lab, where he showcased leadership across domains like firmware, surveillance systems, and financial services on GPU. He spearheaded large-scale web-based systems in e-commerce, manufacturing, agriculture, and development. He served as for the Mindy industry for WRD readiness program, assessing 30 manufacturing SME with a decade in manufacturing as a product processing. he shifts to Sungai, gaining another decade's experience in telecommunications and electronic design automation in with Eureka and let's give a warm round of applause. Yes, Samsu.
Yes.
Sorry, can you readjust the camera that we can see TS Samsul as well? Thank you.
Oh, that's why. Blockchain borders. Bring it into the manufacturing, because manufacturing have not touched the blockchain that much, especially in Malaysia. In outside Malaysia, there's a lot of use cases, especially in the supply chain and traceability. So what is the blockchain? On the very high level, blockchain is part of an umbrella technology which is called distributed ledger technology. The term blockchain actually is only referring to the method how the data is stored. It's a chain of block that is encrypted. There's some other way how the information can be stored using graph structure, all the things. Some of the blockchain network is using different kind of storing method. So blockchain is just how people interchange between I 4.0 and 4 IR. So this is a blockchain and digital
distributed ledger technology. So when we look at the blockchain, there are three areas: data, the logic, and the network. So when we look at the data, what does blockchain offer? Immutable data. This is the core fundamental things that blockchain offer. It means that the data that you put into the blockchain cannot be changed. It can only be appended. You cannot delete. Why this is important? For example, if you want to automate a system between vendor and a customer, if you want, why you still need the human in the middle? Because the human will do the checking. I confirm this is your order. You confirm, yes, this is my order. Because there's the trust in between, it's not there. So if you use a blockchain, you don't need the human in the middle, because both sides is using the same data that is stored, and you cannot change it. If there's any dispute, we can always go back and say, this is what is stored in the blockchain. I mean, this is the base of the cryptocurrency. So it is to track something that you can change. Transparent. Why it's transparent? If you join the network, then you have all the data. So it means that if I'm a vendor, you are a customer. If I join the network, I see the same data exactly like what you see. It's not that I have another part of the data that is you cannot see. So that's the transparency. Authentic is a control. It means that we sure that the data that is recorded is authentic from the right person, the right entity, the right time. Anonymous, this is privacy. Cryptocurrency run based on this anonymous privacy. It means that you cannot track who you are when you do the transfer. Second part, network. The blockchain network run on distributed computing. You have a lot of nodes that running in different physical computer, different location. It's up to you how you want to configure it. So the first generation of blockchain, the Bitcoin implementation, support these two. And decentralized. It means that there's no centralization. How you determine who can change the data, who can add the data, everything is done by the system. So they have the mechanism, the algorithm to determine who can add in the data, how you do the validation. Set executable algorithm. This is what you call the smart contract. This only comes after the 1.0 version. The first version is only storage. Then when Ethereum comes, then you have the smart contract. Smart contract basically is a logic. It's a simple programming that also store on the blockchain. It means that once you store it, you cannot change it. And the smart contract have the ability to change, to access the data and append a new data to it. So this is the basic features that is provided by blockchain. But the hard thing is that for us to interpret from this into a use case, how these three combine to become a use case, for example, to track the vaccine or to track the validity of the halal certificates. So this is use cases. So you need to be able to look at this characteristic, then interpret it into use cases. From the technical point of view, the blockchain, so it is only a storage method. Store binary data into a data storage. Actually, it's more basic than a normal database because it doesn't have all those built-in indexing, whatever. You need to build it on top of it. So the blockchain itself, it just use the encryption crypto to store the data, then make sure that it cannot be changed. Then you have the smart contract that adds some logic to what are the things that you want to write into the storage. The rest basically is done by the application. Whether it's a transaction, whether it's a token, NFT, any kind of tagging, this is all from the application point of view. From the chain point of view, is a basic encrypted data that is stored. From the network point of view, so if you look at any computing, you always have processing and data. So you do processing data, you come from data source and go to output. So what you have is a computational unit that consists of processing and data storage. So this is the logic, this is the data. So a single node within the blockchain basically consists of this. Then you can have network of this that works together. This is the sheer network. This is distributed computing. It means that if you are old enough and you know Napster, BitTorrent, these are the peer-to-peer network, the early usage of the peer-to-peer network. So like if you use BitTorrent last time, so you start up the BitTorrent, then start to list what are the other BitTorrent node that is available that you can share the information with. And once you also up, you also become one part of the network. So this is the basic foundation how the blockchain works. Once you make the node alive, then it becomes parts of the network. Then it share the data. So from the distributed computing, all the node in the blockchain is not like it's the same. You can actually configure it to do different things. For example, you can have a full node that have a full computation capability and full storage, or a half node, no computing, only storage, or a light node, a minimum storage. So why you want to have this flexibility? Because if you want to deploy on a different kind of hardware, then you can choose what kind of nodes that you want to use. So when you combine all this, you have this is what called the layer architecture of the blockchain. At the bottom, you have the data layer. So this is all whatever that happens within the data layer. Then this is the peer-to-peer network. Then consensus. This is all the way until the application. So you can see the application can be cryptocurrency, IoT, NFT, healthcare, anything that fit to the feature of the blockchain. Then from the blockchain itself, you can put, so this is for manufacturing. So now we move towards how this blockchain is applicable to manufacturing. So you can have a IoT layer on top of the blockchain layer. Then you can have the sensor RFID layers on top of the IoT layers. And what kind of things that you can do with this? Smart maintenance, quality assurance, and some other use cases. So you can actually put the blockchain as part of your smart manufacturing implementation. Not going to go through this. You can refer to this later on. This is a decision tree. It's not everything that you have can be solved by blockchain, because to implement blockchain can be expensive and can be very hard. So you need to be very sure whether you need it. So this is the decision tree. So just follow this until the end, then tell you whether you can use blockchain to address the problem. So in manufacturing, blockchain smart contract can be used to minimization of paperwork, reduce turnaround time. That's why I say a lot of process in the manufacturing. We have the human in between because you don't trust. From one department to another department, from vendor to customer, customer to the vendor. So you always want somebody to go in and check. Yes, this is correct, then I approve it. But if you have the data, the transparency, it means that you can always, you are looking at the same data, and this data is something that cannot be tampered. If there's any dispute later on, you can always go back and look at the trace. Who changed the data, when it was changed. There's no feature of deletion. In a normal database, you can always delete. So if you are the root admin for the DB, you can add and you can delete without anyone knowing it. So this is what the blockchain offers. That means that you cannot remove, you cannot delete. So if there's a dispute, you go back and you always can trace back how you have come to this about the data. Supply chain tracking and tracing. How you track the product from concept until the customer. Warranty management. So for example, a lot of use cases that people use now in the university is the e-scroll. So some university like Unisa, Unimap is looking on, a few other universities, is to convert the scroll, the certificate, I mean the diploma, the degree that you have, into the digital format, and it's locked into the blockchain. Some universities start to put their transcript into the blockchain. Then this is used by the company to verify. It means that when I'm doing hiring, I can go to the system, then I'm confident that this is the information is provided by the university. Smart factory, if you look at this is some other use cases where you can start to consider the usage of blockchain. So this morning, I think Mr. Ricky talked about the CPS, the smart manufacturing, talk about the IoT. So when we talk about the cyber physical system, always talk about a distributed architecture. But so far, for most of the time, when we implement MES, ERP, IoT, it's all layered. So by right layer, this is the 5-layer architecture. This is the old 3.0 architecture. The future, the CPS is supposed to be distributed. So this is another example from Fraunhofer. Even within a CPS system, you have all this, and all the CPS nodes are connected together. So it's a distributed system. why you want to do this. No single point of failure. So if your IoT always going to the same gateway, and if the gateway out, then the whole system will be out. So if you want to support something like this, so this is normal IoT architecture. I can have a sensor, then go to tractors. This can be the edge computing, then go to gateway. Gateway can go to cloud. And you can have a lot of other edge computing in between. But if you run this on top of the blockchain network, basically your connection is not bounded only by the red line. So you have all the redundancy, to address out the single point of failure. So even if one of the gateway fail, but the sensor will still have the option to send to the other gateway or even directly to the cloud. So this is built in to the blockchain network. So this is an example, like there's few ways how you deploy the IoT architecture. One is direct connection to the blockchain. So it means that all these things, the edge computing actually running the blockchain node. Then this is where you need the different type of blockchain. It means that the light node may be running on a smaller edge computing system. Then you can have maybe the full node running in the cloud. So you can combine this basically and to cater for a different kind of IoT architecture. One that go through a single gate or a gateway or multiple gateway that go to multiple blockchain. So you can build that the redundancy and also the network by running on top of the blockchain. Can you run this on a normal database? Yes. But you need the expertise of the DB cluster to make sure your master slave configuration, whether master, whether how it's running and all the backup synchronization between all the database and everything. So this is the manual job basically. This is what all the banks, Visa are doing. Now basically when they are running on a traditional database. So what is the challenges to introduce the blockchain? There are what we call a scalability trilemma. The blockchain is what we call a constraint and compensation between security, scalability, and decentralization. In the network, the distributed, you have the 3 CAP CAP. So for blockchain, how do you read this? For example, if this group of blockchain, Hyperledger, EOS, offering security and scalability, but it lacks the decentralization. Because when you want to scale, if you ask this 100% decentralization, it will be very hard. For example, decentralization for Bitcoin or even Ethereum. It takes maybe 7 to 10 transactions per second. So that's the performance. But you compare to something like Hyperledger, which is not fully decentralized, it can go up like 2,000 transactions per second. So the same thing, if IOTA, for example, IOTA is quite famous for blockchain implementation in IoT. So you offer the scalability and centralization while it lacks of security. Another thing is that IOTA will support smart contract. So from these are some other areas where the challenges in terms of security, scalability, performance, and interoperability. Example of this is from a paper. One of the famous use case that people use is the maintenance, to track the maintenance data from the IoT system, from the machine, end to end, for maintenance automation, scheduling. Because what they found out, a lot of data discrepancy in the production line between the machine and also what is reported by the engineering. So if you run it on the blockchain, then they will be using the same data. Supply chain. We are using Hyperledger Fabric as our blockchain network. Why we use Hyperledger Fabric? Because it's a permission-based. So it means that we can protect some of the data. It's not totally open like Bitcoin or Ethereum where everybody can see everything. Because from company point of view, I can have a channel, special channel between I and vendor too. So it's a privacy. I don't want anybody else to know the information between my company and the vendor too. Or I can create configuration that you can share vendor one information with customer one and within the same blockchain. So that's why this is where you need to use the permission-based, configurable-based network. So that's why in our case, we do a lot of things for the government. So they always partition between the different department and everything. So then we use the Hyperledger so that you can set up the different group of people that can share the same thing. But we have founder nodes that have access to all or everything. Okay, that's all there. If you want to read more, these are some of the references in the presentation. You can get it from the organizer. Thanks.
Thank you, Tian Samsul, for that enlightening presentation. Next, I invite Mr. Azhar Mataja, country site leader at Everyday Listens Smart Track, to share his expertise with us. With over 30 years of experience, Mr. Azhar has led local and global teams in innovating high-tech products, emphasizing future technology prepping. He advocates for continuous learning leads by example, fosters growth mindset, and mentors future leaders. His approach blends practical wisdom with forward-thinking vision, nurturing talent, and driving technological advancements. Let's give a warm round of applause to welcome our last speaker, Mr. Azhar.
Okay. Good morning. How are you guys doing? Okay. Good to be back on the stage after more than a year. All right. Yeah, I can see so many blue shirt from Greater. Let's go to the 2, 3, Iketan. Do you guys know what was your revenue in 2022? Greater. Any management team? No. Wow. How many of you have a problem at work due to quality issue? Can I see your hand? Only one, huh? Sure. No issue. Okay. All right. Never mind, later I'll go back to that, why I asked that question. So, yeah, the topic given to me by the organizer is to talk about how we balance between investment and also innovation with regards to Industry 4.0. So it's not going to be straightforward, but I'll make it a little bit more easy to understand based on my own experience. So, yeah, I'm from Every Denizen. I don't know how many of you have heard Every Denizen, what we do? Can I see your hand? No. What company is this? Yeah. So let's start with this quote from, you guys know Steve Jobs. Okay, late Steve Jobs. He said, the ones who are crazy enough to think that they can change the world are the ones who do. That was his time before he passed away. But you know, who is the most craziest person on earth right now in the high-tech industry? Who? Another person? Yeah, this guy, right? I think almost every day I can see on the TikTok and also LinkedIn. He said software is eating the world, right? But AI is going to eat software. I think when we first started Industry 4.0, yes, Chamsu was the best student at that time when we embarked on Industry Forward certification. At that point of time, we thought that, wow, send all our kids to learn Python, programming, blah, blah, blah. And recently he said, no need. He said, what? You must be domain expert. All of us are mostly a domain expert, except the Imran, he's the software guy. That's why he organized this. But what he means by domain expert, things that you have heard since morning, those are important for us to be the best domain expert or subject matter expert in the domain, the things that we do, the subject matter based on what we are expert in terms of process, technology, and whatnot, right? Because it's easy to say that I want IoT, but you don't know what kind of problem you want to solve, right? So it's very important today. Some of the bosses say, oh, my people have a problem causing quality issues. But what kind of technology which is suitable to solve or address the issues? That's why all of you are here. Go back and tell your bosses how Industry 4.0 can help them to increase their profitability and solve all this problem. Okay? Okay, every lesson. We started with adhesive. This guy, the founder, Ray Stanton or Stan Every, he invented the first world, okay, it's patented, the first world self-sticky adhesive, self-adhesive that can stick by itself about 89 years ago, many years. But why I share you this story is because this is how we started. But where we are today, okay, this is what we achieved in 2023, 8.4 billion USD revenue. Fortune 500, 421 in 2023, employee about 34,000 across the globe. In Malaysia, in Kulim, we have our manufacturing where we do RFID, can partner with Memos. RFID, and also we have R&D, the only R&D center across the globe where we do innovation on how the future RFID will look like, all based in US. Okay, but originally we started with material group where we produce a lot of different kind of high-tech material, especially in adhesive, including the car wrapper, if you are a fan of the car wrapping. But along the way, we realized that we cannot go away or we cannot ignore the opportunity in the digital transformation. So that's where we started the solution group, okay, where one of the so-called division within solution group is RFID solutions itself, where we embedded RFID into any kind of labeling sticker and whatnot. You can see it everywhere, right? You can have sticker on the bottle, on the boxes and all that, or carton boxes when you ship your parts, or even now, in your car lah, right? RFID reverse, right? Soon they're going to use ours one, so we solve that problem. But to be frank to you, that's not RFID tech issue, or that's a back-end software issue, okay? They don't want to make it fast because they cannot cope. So they told us, make it slower. Until they don't have to reverse, but a bit slow. Okay? But don't tell them, I tell you. Okay, so we do a lot of things. So when we transform our business model, we merge with the digital and physical and virtual world together. That's where we ended up in a new solutions, right? Where in the European and USA today, they mandate a lot of new law, including you buy a shirt today, you have to know where this shirt come from, who manufactured it, Azar, Dr. Imran, before end to end, before it go into the landfill or you dispose it, who dispose it. So to that level of kind of mandatory requirement in terms of how they regulate the law. So that is current, but probably we are far from that. Okay. So what I will cover in the next few more slides is about how you monetize the pain point. As I asked, most of the companies, especially manufacturing sector, they have quality issues, right? But how do you monetize quality issues? And quality issues sometimes or most of the time related to human. So how do you monetize the human productivity loss? And when it comes to human, also some of the human say that this is boss issue. Go back to management, right? So I put up there a bit smaller, I don't know. The power of 1%. You want to read what is it mean more about the power of 1%, go to LinkedIn. I have that article written. But later I show you how 1% is important or translate into monetary. Okay. And encoding and decoding. Some, I think Ricky talked about dashboard, data visualization, and so on. Many people, when they wanted to start Industry 4.0 journey, they will start with dashboard development. But how do you monetize all the software-based kind of application? And of course, call to action. I call it start fast and win big. T.S. Martin said, start small and win big. That was probably 8 or 10 years ago when we first started, especially in Malaysia, when we have Industry Forward launched in 2018. But now we cannot start slow or we cannot start small anymore, to be frank. If we start slow, start small, we'll be behind. Because we are 8 years behind in terms of Industry 4.0, 3 different waves that already been launched since 2009. 2009, 2016, first wave, 2016 to 2025, where we are today, the second wave. Next year will be the wave, final wave before we officially enter Industry 5. Okay? Okay, monetizing pain point. Okay, what does it mean? I'll give you a simple example. We have a lot of pain points. Pain points can come from quality issues, machine breakdown issues, or product development issues, or even talking about waste, scrap, the Ricky talk about lean, where you minimize waste, all those I would say is common in the, especially in the manufacturing operation today. But I give you some example here. A few key metrics, which I believe in most of the manufacturing company have it, right? Things like OE, overall equipment efficiency, below target, depending on what target you set. But you should have a target in terms of what define your yield, availability, performance rate, in terms of the quality target, whether it related to customer return, incoming, outgoing, scrap, waste. You should have a target. Service level, on-time delivery, lead time, UPH that you set. You should have a target. It's not just about manufacturing. I think any company also should have a target. In terms of the other side of the matrix, people. Every part of us, unless you are self-employed or you own a company, any one of you own your own company? No, right? We are all employed. So we work, right? We got paid. But every single little things that put into the company is a resource, right? That's why we call it human resource. But all those are not free, right? We do work for free. So all those are money. So in terms of labor hours lost, problem solving, how fast you can solve problem. I think T.S. Martin shared one of the critical skill by World Economic Forum is talking about solving complex problem. It's not just solving problem. So solving complex problem, meaning you need to have a new way of doing it, new tool, new technology. Meeting. We spend a lot of time in meeting, but have you ever wondered how much time you spend on effective meeting at work? So how do you minimize the losses, right? And monetize all these things. Culture, value. Some company or most of the company talk about my company don't have a culture, don't embrace core values. But when you say that, how do you monetize all those things into money, right? And other things, loss of customer trust. Suddenly, customers don't want to buy from you because quality lousy, right? For example, managing supplier, so difficult today, especially in the manual world, right? And firefighting, well, every company, I think, mostly have this common way of approach, right? Firefighting every day, look at numbers and so on. So all these are potential or areas that we can focus, transform the pain points into monetary gain, right? So if I take example of Raytech just now, I look at your financial 2022, because you're probably listed, right? 420 ringgit stock price today. 546 million annual revenue. 1% of that, how much? How much? 546 million ringgit. 1% of that, how much? 5.4 million or 5.5 million. Is that a lot of money? Raytech? Lot. Right? Just 1%, right? If 10% improve, because today your profit ratio is 24.5%. Still can improve, right? Still can improve 1% only. So today, go back, you meet your letter 3, tell him after this forum, I teach you to get a promotion. Go back, all of you, bring back. Make an appointment. Alim also here can spot. Alright? After this Industry 4.0 forum, I can help you to bring 1% additional profit. 5.4 million. How? Industry 4.0 investment is only 2 million. Okay or not? 2 million invest, 5 million gain. Okay, I do a teaching. So that's what I'm trying to say. 1%. Maybe it sounds small if you just talk about the numbers there. You have to monetize. Okay? I'm not talking about retail, the rest of the company, maybe Intel more billion. So look at the numbers, translate, don't just talk about technical, because you guys mostly probably engineers and so on. I know I was an engineer before, but we have to know, or we have to have business acumen mindset, right? Understanding the financial. Yeah, I'll give you an example. For example, this company, not Raytech. OE 45%, quality issue, related to quality issue, all the losses 500k USD, but this is not evidence, don't get me wrong. Service level loss 800k because of firefighting with the customer run away. Run rate about 6 billion unit a year, revenue about 120 million USD. So if I improve 10% through innovation in Industry 4.0, there's already improvement of 100k. There are a lot of computational algorithms here. Quality issue drop, I gain 300k and so on. So OE gain alone will produce 300 million pieces per year. If you're talking about capacity. Most of the company, when they started, it's about 40 to 50%. World class 85%. I think all of our experts here will understand about all this. So you can see here a lot of gain here. You should show your MD or CEO or whatnot, right? All these numbers before you start talking about investment in Industry 4.0. Then definitely they love this number. And of course, translate that, get your finance team to buy off all these numbers and translate into real financial metrics. Okay, in terms of payback period, NPV, internal rate of return, because you have to invest on software, hardware, and others. Still manageable in the big picture. But the detail, of course, you all have to work out. Got this? Okay, very tight. I'll follow up with that's you. That the Halil also can follow up. Okay, encode and decode. Monetizing raw data into information and decision. Because we deal with a lot of data. I think most of the speakers talk about data. But raw data is not going to go anywhere if you don't process it, right? So once you process it, what's the next step? You need to make decision, right? Good decision to improve and also move forward. If I have data, I have information, it's not good enough. I must make sure that information itself can translate into money. We do business for certain reason, right? We not just do business for fun, right? So money is the end, right? Results oriented. So this is the flow. There's a simple guideline flow. It can be more complex in certain application. We deal with raw data, like in manufacturing, mostly we deal with operational metrics, product specification, need to fine tune here and there, process and machine control data, a lot of data, right? And then from here, from raw data itself, most of us will start working on dashboarding, data visualization. And the typical request is, I want it real time. I want every 5 seconds, then the whole computer jam, right? The whole programmer so think so hard how to make that happen. In terms of encode, we translate raw data into data visualization. That's why we always see dashboarding. And we decide on what kind of frequency, what kind of trigger limit, what kind of closed loop watchdog system that you would like to put in place, and remove all the noises. A lot of unwanted data that normally make you very, very difficult to make a decision. And then you decode. So this is where the domain expertise come into the picture. From this, encode and decode. How you want to use this data? Is it just passive, show off on the screen, and then when we have visitor customer, they're happy to see? No, I want to see my CNC machine. Every time I have problem with my CNC machine, what is the root cause? Instead of boss come and ask you to think away. Okay, what caused this, right? So immediately I know the root cause. The system itself can trigger, this problem is this root cause. Before you go into preventive, because before you can build that preventive, you must have all this so-called corrective first, using the technology. Immediate correction, self-correction in terms of TMC parameter and let's say cutting them and whatnot, right? Suddenly it switched to something else within the spec, but it's not optimized. Immediate alert and trigger. Trigger the PIC to immediately look at it. And you can make a decision less than 5 minutes. This is so good, right? If I can make a decision as a management team, I look at data group, 5 minutes can make a call. Some company can go 5 days also no decision, right? Prevent reoccurrence. No more repeated case. That's very important. And finally, outcome. Look at our KPI, whether it's improved or not over time through all this cycle, right? Financial impact. It's very important to go back to your financial numbers and performance. Whether you achieve your goal and celebrate the team and see whether how agile are you moving forward, right? So this is the cycle, simple cycle. Trust me, you follow, you'll be successful. Call to action, start fast and win big, right? Don't start small or don't start slow anymore. But I will introduce to you, have you heard of POC before? What is POC? Robot concept, right? So today I'm going to change that. New standard, pattern. Okay, team formation. Who should be in this team when you want to kickstart your industry 4 journey? Even though, we are late, but we have no choice. We have to start somewhere because I can see a lot of new faces here. Technical team, whether it's engineering and so on, finance, planning, quality, procurement, IT, and production must be in the team, not just engineering talking about it, then you short scenery. Okay? Monetizing all pain point. So this team has to monetize. You don't spend about what system you want to buy, what technology you want to adapt or adopt. Monetize first. When people walk slow, how much it costs to your company in terms of productivity loss? When people, I don't know, sleep or what not, at night shift, and night shift always lower productivity compared to morning shift because they have to take bus from very far away for, I don't know, from kampung somewhere, right? When they come to work, very exhausted, fatigue. So how you make use of technology to address that? Monetize it. Set the goal, timeline less than 6 months. Don't go beyond 6 months. Too long, right? Too long. So do something within 6 months or shorter. Move from POC to POV, proof of value. Okay, so I coined this term. Proof of value using money. People love to talk about money, right? Who don't want money, right? So please create that excitement, proof of value instead of proof of concept because we don't have much time. Shift focus from feasibility to value. Look what kind of value you can bring by implementing this solution or that platform. Emphasize on tangible and also ROI, right? That's a financial thing. Accelerate stakeholder buy-in and adoption. Who are your stakeholder? Whoever that interested about addressing the pain points that I mentioned just now. Make sure they are aware what will be the benefit of all this new application or new solution. We are behind by 8 years, as I said, keep going, don't stop and keep going, don't stop, right? Don't give up. Learning from mistake and success. I think TS Martin talked about mistake, it's good, but don't repeat the same mistake over and over again. But also learn from success, other people's success, not only within your own organization. Focus on solving complex problems and create value adds. You have to love to solve problems because if you are engineers, I think that's our job. When all those creation, innovation that came up in this world also, everything started with problem. Okay? It's not something that just born like that. So let's embrace this, and I hope that you have gained something from this session. And of course, you want to know more about our RFID product marketing slide. Okay, looking for RFID, if you're looking for RFID blockchain, we already started actually. We have a lot of application everywhere. Sometimes you don't know there is an RFID when you go take your luggage at the airport, right? When you go and do whatever screening, sometimes RFID is inside secretly that you don't know. Okay, so I tell you already, so you know. So all kind of application can go to our website. Okay, that's all. Thank you very much.
Now is a forum session, so I would like to invite the speakers to be in front. Open Zero Maturity Assessment and Roadmap. So we will be having 2 questions, and then we will open the question for the floor to ask. Okay. So firstly, please give a big round of applause to the all of the speakers. So my first question, basically to the honorable panel speakers over here. We have Mr. Ricky Seo, T.S. Shamsul, Mr. Usman, and Mr. Azhar, who have decade of experience in implementation of IR 4.0. IR 4.0 itself is quite big, and not one person or one company can cover end to end. So there is IoT with the physical sensors, machines, and then communication, then edge. And then from the physical, where you have a IoT, robotics, augmented reality, 3D printing, and it goes to the digital world. It's entering into the cloud. So from that digital world, the data is being managed, stored and managed and analyzed and then moving towards artificial intelligence, and end to end, just like mentioned by the speakers earlier, is cybersecurity. So the first question to the honorable panel speaker is that uh, Industry 4.0 implementation, everyone wanted to move towards that digital transformation, but there are many roadblocks. So as I mentioned about POV just now, so what is the most important? Do we need to start from the physical world towards the digital? Or do we need to start with the data monetization of POC or POV first? Once the value is being gained, then do the investment on the larger scale. So maybe anyone can take this.
The reference speaker. I think I come from SAP and a lot of system integration or enterprise application. Ask you this question. I always say that you have to start from as a sharing because it comes from business, the company itself, you know. And, but because it's you see why you got industry, first industry, second industry, because just now I'm trying to changing of the technology to make the difference of the methodology and all these things. So could it be an industry 5.0, 6.0? It will be because of technology. So, but we are still doing the same thing, right? In the business policy. I would say that you must understand what is the state of the art and technology. Imran was saying that you must know human blockchain. I learned a lot from blockchain. You must know the industry, and you have to know what you want, your business pain point, you're addressing what you interesting, and then you have to leverage the latest technology. That's why you need to know the technology. That's my thank you.
I will answer it as a unit, basically your problem solved. The engineering methodology has been there for ages. So you just need to follow up this discipline, like problem solving methodology. Yeah. So now when we talk about the industry 4.0, it's just the two. How this combination of technology to address your problem. And that problem has been the same problem for most of the manufacturing. Optimization capacity. Is everything all over again? Is it just automatic that
Again, if you look at the trends, industry 2.0 to 3.0 movement, where the main value came from the automation.
20% cost of sales, right? That's already what? 100 over million kind of cost. So if I look at that, what of where we can reduce by investing something in technology, what your people definitely will go one day there, you can easily tell you what will be that thing. So go ahead numbers, if you don't know how to assess for the thing.
So my next question is, the evolution of technology is very rapid. Whatever is relevant today may be obsolete tomorrow. And Gen AI, ChatGPT was coming into, now Sora is coming, where you can just write the things and the vehicles that it should be there. So in Industry 4.0, already they wanted to foresee people are important. And then without people, there is no transformation. It's not about technology, but it's people with technology. So for the people, they require skills. Now there's so much segregation of the skills, IoT, analytics, AI, blockchain, cybersecurity. So if the audience wanted to work, for example, in terms of digital transformation, really they should start in terms of transformation, individual and organization. For the skills, I will repeat, for the skill development, you should start as an individual and as an organization.
Yeah, I will not on the technical, if we will do the right thing. Start with the mindset, in terms of developing the right mindset from the point of view and also the human point of view. So when you have the right mindset, then you understand what it is before all about, the leaders will actually that first. And then after that, looking at the gap, the skill gap. Today, the leader, most of the company work out the that's not a skill gap to me. You want to make use of your initiative and on and whatnot, right? Today you can make use of your own money, but that's not your objective. Change your DNA into another model. Look at competency to match with Industry 4.0. In terms of the technician, we are do something on positively trying to reduce the number. Look at the JT. When the Industry 4.0, you need to implement solutions. What you will keep on doing, the demand, looking at 20,
I think it goes back to fundamental thing, which is in the past we looked at the learning, for example, certain technical things. It's in the last 5 or 10 years, it seems like we can learn anything as far as being fintech. We have a program coming in. All the way to a fact. So learning is about the home, I think. The mindset. That's so wrong. Mindset, and within the mindset, we need to have a critical thinking, critical thinking, which will really explain the perspective of how we look at the problems. So again, for me, when I basically work with my teams, stakeholders, one of the key things to promote is the mindset. So the mindset needs to be changed. And secondly, also, people need to be proactive. You need to step up to do things. Unfortunately, I think most of the people maybe that in our culture here sometimes there are not many people which do initiatives. So we need to have those things as part of our building, growth, and then we grow and we project blockchain, IoT, or so many things. There are many opportunities. Thank you.
I think nothing about it for curiosity, the motivation to learn, especially For example, like our generation, even years before, over my lives, basically the career, moved in a lot of different areas. And once you are in this, then you need to be motivated. Then I think we are in the era where the access to the information is given. You can access it, anything that you want. Then now just that you need to learn how to learn. It means that there's too many information. You need to, okay, first define it, then synthesize it, distill it, then figure out what I want to do, how I want to do it. Structure it is something that I can understand for the things that I want to do. So this is learn how to learn. Because the information is there. You can ask a lot of things from ChatGPT to answer. So it's just that you need to know what you want to learn, what question you want to ask.
I think during these questions, I think the panel has been JD mindset and will talking with the culture, teaching the culture. I think it's very difficult. So the each one has to come with a need for transformation. So it's not and also for JD, then you move for people in a kind of skill set that you don't want to have it's and that was and then when you look for JD, I think you need to move to skill competency. I'm sure all companies have a skill competency. They do a performance evaluation. You have that kind of metrics. You can feel that is improvement in these things. So curiosity, something to answer the question as an individual, I think the young generation are actually very different, right? So they have the and person to learn everything. And as a company, as a group, the company have to drive the culture, and we have to know what kind of skill set we need. I think that just how we even say there's so many technology, right? I'm going to learn blockchain for this company A, company B. This one, and the key first for AI. It's an opportunity, right? It's probably we say, oh, AI is right. We're still learning by learning. So you learn, after learning 2024 is something really come on there, really something that it's an individual. Company itself must know your to go to I said, not only the process can, as I say, the people can. Thank you.
From outside this, which is meaning the AI should be managed to fail fast. But in Asian culture, if a person, then the organization, whether it's a SME, MNC, GLC, and so they will able to take it as something negative. So they will say that it's an individual failure, and most of the time they will not be giving that person or that team the opportunity to innovate. So how to change the mindset as a leader? Any thoughts on that? Anyone can answer.
I think personally what I think was because the people turn a lot of people I think that first one of the biggest problem especially when people look at doing their KPIs for the year. Example, like somebody commit to do a certain project a certain year, and they know their goals is they're dependent on it, but they will be always be
we can get the growth benefits, but then they will take less space. But eventually, I think it's going to become a company where probably 20-30% of it will be over here with they have advanced technology. In my organization, we start working with in this case to do some risk taking. And it also goes back to the whole just so people are too much I don't with year to year like the future. And if we look at the bigger picture, potential and the things, the big things. Personally, myself, my team, for about 3 years. This one's up there. That's one of the bigger picture. I can, oh, sorry, but I can only add to minimize the failure of this because again, once a project which is this project and is transformation for transformation is self transformation. Like I think through education or education to our planners, we have to say that the project is important, but then we have to take time. So coming back to minimizing is to always, if you can, I know Malaysia, we are running out of time. If you can, we to first project and to do low hanging fruit, or I like to call it quick win project, and do a lot of studies on the referencing, the labor or state industry, and done things to minimize that. Okay, thank you. I think my business is we can minimize the failure by applying agile system in which the iteration of 1 week and 2 weeks can able to make it. We can able to minimize.
For example,
Using technology of a step is talking about and we didn't really something. Even I think we all of our and to focus the working model process of various building or protocol blockchain that allow capability and moving the AEO, the authorized it's very hard. Of course, we have thought that Malaysia have all talent. I mean, things from wafer all the way to the finished system and everything in between. But we build it for us. So what's the skill of Intel? All the together we can work to the common goal. That's the thing that for me is one. Isn't it? We don't know how to get this to work together. Even if for those people that, for example, there's a lot. Why we cannot start with Malaysian companies? I think some people say, Mr. Sorry, so you have something that is the law of this thing get into one tomorrow. That they break down to smaller, like so much. So okay, let's thinking of working on these days more a lot of vendors, right? A lot of stakeholders. I also hope Malaysian governments, MNC and policy can get together to do this non-working model. Again, the working model of the use cases for MNC size company, we're talking about 80 to 100 million company, and large enterprise will be different. Thanks for asking very good. Basically, if you look at the technological point of view, I believe we don't have any point of view, I don't think we have issues. Now, where are the issues? The issues basically come again into, let's say, one into two parts. If we are starting a new factory, or we're starting a new, whoever is going to invest on it, they need to see the return of investment. Because the good was left among there's a high possibility of adopting and implementing. And I think if you look at most of the coming out in case studies, you can see many companies are really adopting as well on the new one. There is some also from the thing already operating with the legacy one. If you talk to the customer which are working in that type of legacy system, they're speaking when they set up the method of setting up Intel. Let's say they set up the Intel factory in US. They will set up they will replicate each and everything as it is. Therefore, even to the level that screws will be procured in the same place. Because there is a risk of money. So that is one part of the challenge. So I think the newer the factory probably. We also need to think about another example. Remember when we were using feature phones? Eventually, people start moving into smart life. Because certain things that they can't do at all with the WhatsApp and email to the world. If you get far at least, now for 4G, was part of it to put in. I think that varies coming. That definitely is a very definitely coming in. But one part is business, another part governance and the policy. I think that if that framework comes into it, probably. So when they set up the country, they do replicate the same way, but the important factor there is the last couple of years. As we are also implementing AI and IoT. They also become not only to for themselves, but also provide others. So I've seen from the case of the
Yes. Majority assessment. I'm not sure we have yet. In the survey, my office with Asia School of Business in 2000, we came up with a report February. Report came up with that the take-up rate is very low. It's not bad. The overall country value. I think this report is available at PSB. Still have a copy and have it here. So that was survey done end of 2021 to end of 2022. The 4.0 awareness and I don't think that we have come to that maturity. So many talks about I4.0, and now the wave of AI is coming. I4 might be not so relevant.
So I like so the question asked is what model, how we move forward. Being one who is a former state exco for industry over the last 5 years, now not to say I'm retired, but now I go around the industry. I'm this passionate, moving around to see how we could improve. Pinang has registered very 71 billion in terms of FDI. The challenge is for MNCs. We have 300 over MNCs. They have the capacity to invest to continue improving. But the concern is the SMEs, the local large companies, whether they have the capacity. As I mentioned, that you need 2 million to invest for I4.0. The question for many, the issue for many SMEs is that to invest, they always wait for the government grant. That's the issue, and then they need to reskill their workers. Those are the issues. But what I like Martin shared on collaboration. TS also mentioned that in one industry alone is not enough. Yeah. So collaboration is so important. The ideation is so important for us to grow. And what I'm most important for me is leadership. We need leadership. State has already put 2030 smart state and all that, but then leadership, somebody to carry the cane, to ensure that this collaboration between agencies and then also private, state, all the stakeholders need to work together for this. If not, we'll be left out. You like it or not, technology is continuously advancing. Why you need to go for I4? Why you need to go to adopt this AI? You'll be left out. I'm completely concerned, even though we could keep continuing to be the state #1 state for investment, but one who was formerly with the state expo, I could feel sustainability is the issue for Penang. We may do very well now, but the next few years we may just go in on the side. If we are not ready with the talent, we are not ready with embracing the technology, we are not going to get anywhere. Thank you. Sorry, it's not question.
Okay, thank you, Dato, for the feedback. So I think now we will proceed with the token of appreciation to the speakers and the group photo. And then we will be having a small session about what is a maturity assessment. how we can self-assess in terms of people, process, technology, and also data towards the AI. Okay, so let's have a token of appreciation. It was quite interesting. Questions.
Okay, so at this time, I would like to call upon TS Dr. Muhammad Imran Salwa to come on the stage for giving token for appreciation to the panel speaker. I will call upon our first speaker, Mr. Ricky Shirkisan. Mr. Fergus will take the photo. Okay, thank you. The second speaker is Mr. Usman Sawa. The third one is T.S. Martin, Stephen Muller, you get later on. And then the fourth one is T.S. Samsul and Abdul Wahid. So the last speaker is Mr. Azhar Nayan.
Martin will be in the middle. No worries, Martin. We will take a photo of you then.
Maybe the other participants online can also switch on their cameras. Then we have a group photo. I don't know, maybe. We'll take it in this way. Okay.
Thank you very much. Now we will be having a small important session regarding the maturity assessment.
Yeah.
We all should the time. So
session is regarding we discuss about the industry 4.0, technologies, people, skills, process. But what is the way forward for us? The most difficult is to do the evaluation. Okay? So evaluation, so we were in a phase of digitization in 90s where we were converting into paper into digital format. So that is called digitization. And after that, from the Word document and Excel, we do some analytics and graph. That is called digitalization. And now we are in a phase of digital transformation. Means that from there, data we are forecasting using artificial intelligence and machine learning. So that is a digital transformation. So in your smart factory or in your factory, you have a multiple technologies that are integrating with each other. So one of the speaker mentioned open protocol and standard. Open means that they can communicate with each other. So the biggest problem right now in the IoT is lack of standardization. So if they cannot communicate, your factory cannot able to run and transform. So I will skip some slides. So Ricky mentioned about the Lighthouse certification, which is by World Economic Forum. And WD is one of the only factory who's having that certification. So what is stopping other MNCs to follow or GLC? The reason is that it has too much openness. You have to prove the use cases in the assembly line, in the maintenance, in the performance, even in the data level. So the auditors from US will be able to come and then review, and then from that review, create a report, and then from that report, you will earn a certification. But is our intention is only to get a certification? No, it's basically to have a sustainable ecosystem. For that sustainability, we want people, process, and technology to work together to become a smart factory. So our end goal is to increase the forecasting. So whenever you heard about forecasting, it means that it is analytics with AI to predict what will happen tomorrow, next week, next month. We wanted to decrease the design engineering cost. We also wanted to decrease 20 to 40% inventory holding cost and machine downtime 50 to 60%. And also increase the labor productivity. Why it is called labor? Actually, it's not labor, it's people. So if you see operators in your factory, they need to be upskilled to technicians. The technician needs to upskill to engineers, and the engineer needs to upskill to digital leaders that have a AI competency. So when we talk about assessment, right, we need to assess in the form of people first, then technology, process, and data. I want to give you a formula that it will easy for you to remember. People are part of a process. Process use technology. Technology produce the data that needs to be monetized. So Industry 4.0 is digital people working in a process which is data-driven. From data-driven process use AI-enabled technologies that uses the data to monetize. So that is the end goal in terms of maturity assessment. So maturity assessment, whether it's for manufacturing, automotive, supply chain, oil and gas, even for banking, the goal is same. The same is to understand where we are. Are we industry 2.0, 2.5, 2.9, 3.25? The goal is to go for 4.0, but you cannot go to 4.0 unless you know where you are. So process people, are you 4.0 people? Means you have AI skills or analytics skills. Are you 3.0 or 4.0 process? Are you using 4.0 or 3.0 technologies? And are you monetizing the data? So the maturity assessment is across every pillar or every dimension. So there are many frameworks. This is one of the frameworks that we have included using the Lighthouse 4.0 from VTMA, for Fraunhofer, for Siri, for Industry 4.0. You can select any framework. And the purpose of framework is to evaluate where you are. And when we talk about those frameworks, what will be the output of the assessment? The output of the assessment in terms of people, process, technology will be in terms of readiness, how important readiness you are, existence in terms of coordination among the departments, work capability, vertical integration, product development, horizontal, and so on. There are many. So if I want to summarize this slide based on the comments that we have received from the panel,
we have to start from POC to POV, proof of value. So proof of value will be, there are two approaches, down, bottom-up approach, which is from IoT all towards data and AI. And second is from data and AI towards going down. My humble recommendation will be go from top bottom because it will be more faster, require less investment. What will be the investment? Just a laptop to prove the value of the data. So you can evaluate yourself. So let me ask you one question. This is a very basic metrics from digitalization to industry 4.0. You can score yourself, right? If you are having a computer, means your process are having a digital machine, not analog machine, you can put yourself 1. If that machine have a connectivity feature, means IoT enable, you can score yourself as 2. If those connectivity sending the data to the cloud and you have a real-time dashboard, so you have a visibility of what's going on, you can score yourself 3. If you have a transparency about understanding why it is happening, which is diagnostic analytics, you can score yourself 4. And if you have an AI capability for forecasting using machine learning, then you can score 5. And if you are having an autonomous factory, you can score your 6. So can I have show of hands who are 1? You already have computers in your factory? Should be all. Let's go other way around. How many of you are number 5? Having a predictive forecasting capability of your machines. Okay, let's go one step behind. How many of you are 4 that you can able to have a diagnostic? Excellent. Excellent. So this means that you have the IoT connectivity cloud or server architecture to save the data and have an analytics, what is happening and why it is happening. So the next leap for you is to use artificial intelligence, machine learning or deep learning. Machine learning for your forecasting of the dashboard and deep learning is for decision making of unstructured data. Okay, I will skip that, we have less time, but this is the architecture, digital landscape architecture for smart factory. So you have a couple of layers. You have a development cycle, production cycle, or user cycle, where you are getting the data from many sources. I was in one of the factory, which is automotive assembly in Pahang. So they have a file, which is not the digital file, the normal physical file, and they are doing the meter readings. And then they have to scan it. And after scanning it, then they have to write it. What is the solution? Because the problem is take longer time, they can be error writing it, inputting the data. What is the solution? Solution is using AI OCR, character recognition, that can solve the problem. So they are having hundreds of thousands of ringgit of loss using just couple of thousand ringgit small application. It solved the problem. Okay. So those data is going towards the cloud, and then from the cloud, you are basically making a decision. Quickly, I will just do one thing. So this is the framework for you. It's from your, it's free, it's open. You, whatever you wanted to do, digital transformation, you need to know what you are doing, where you are doing, why you are doing, and how you will do. Okay, we will send the slides to you. Okay, so you have customer. At the end, you have a customer. What is the better serving customer that you can able to do? Okay, so in that cycle is a repetition in terms of digital transformation. Digital transformation is not something that you will able to achieve and after that you will say everything is done. It's a continuous evolution process. So when we want you to do assessment, when you go back, do your self-assessment. You do the self-assessment in terms of strategy, whether you have a strategy to implement that all use cases of POV, which Azhar have mentioned about. And in terms of people, do you have the strategy in terms of going for dimension in terms of customer centricity, capability, agility, and synergy? And when you talk about people, do you have these people? So my question to you is, do you have these people in your organization for the transformation? And who is the most important one? Can you please tell me who is the most important one to start digital transformation? Not all, this one. Do you know? Any guess? From all these, which is the most important person? He or she alone can able to start the transformation. Any guess? Data scientist. Data scientist's role is to understand the problem, get the data, transform the data, and use artificial intelligence. So in the transformation for Industry 4.0 end-to-end, it's not belongs to IT. There's a misconception that IT will be actually all of the stakeholders. And the minimum thing is you need to have a data literacy. So right now we are advocating not only in Malaysia but outside that data, understanding the data, which is data literacy, is an essential skill everyone needs to have. The analytical skills or data analytics skills, not for IT, MIS, but also for finance, HR, QA, QC, everyone. So everyone needs to know the language of data. Why? Because the fourth industrial revolution is a digital or data-driven process. So it's an era of data. Whoever have the data owns it. So data literacy is the most important thing. So what type of skills is needed for different levels? You need to have a design thinking skill, which Martin have mentioned. Instead of design thinking, you need to have a digital design thinking where you can use the AI tools to help you in terms of innovation and problem solving. Okay. So leader, management, and executive level needs to have those kind of a program. And that have endorsed many of the program for many of the training providers, which are for AI and data science space. So the goal is how we can learn about the data and how we can use artificial intelligence for the customization. In terms of process, you need to have a data-driven process. So you cannot fit technology to a problem. You need to go other way around. Understand the process like a domain expert, which Azhar mentioned. You need to be domain expert and know which technology can solve this problem. In terms of technology, you need to have a bird's eye view about IoT, hardware level, then communication level. Usman was mentioning about different protocols. You need to know about the databases and then also artificial intelligence. So what university is producing is specific niche, but what industry wants is generic. So industry wants someone who can solve the problem. Industry wants someone who can learn, unlearn and relearn. Industry wants someone who can able to fail fast. Industry wants someone who can learn things and solve the problem. In terms of data, you need to look into which era you are right now. In Penang, many of the SMEs, they are here, which are using Excel. Most of them are using Excel. So what we are advocating is use something free tool. As per Gartner, the leader for the data analytics tool is Power BI, which is free for the desktop version. So you can start with the Power BI because it's easy to learn. And you will be amazed that in Malaysia, for instance, especially in Utara, Penang and Pune, there are companies which are giving a chance to their HR, finance, QA, QC to be BI and then moving towards data scientists. So traditional BI, you are having the analytics, which is descriptive and diagnostic. Big data will able to allow you to have advanced analytics, which are forecasting and also deep learning based things. which is advanced analytics using artificial intelligence, machine learning, and deep learning. So what's next? I have 5 minutes. What's next? You can able to do self-assessment of your process because you're subject matter expert, or you can engage some of the expert over here. You need to have number 2, digital skills. On those digital skills are Python, okay, Python for customization. Why we are advocating Python? Because when you learn Python, you can program in IoT, cybersecurity, analytics, artificial intelligence, cybersecurity, and even augmented reality. Design thinking, also basically other specialized programs which are related to IoT, DevOps, augmented reality. The most underrated technology in IR 4.0 is immersive technology, which is augmented reality, virtual reality, and merged reality. Doesn't require much of the investment. It can be implemented in your mobile, but it has a lot of benefits. Number 3 is innovation approach, which Martin have mentioned. So the innovation approach means that you have a set up an initiation. You understand, for example, your problem, and also understand your business model towards MVP, which is minimum viable product or project, moving towards building a scale. So you need to have a design thinking methodology, business model, lean startup, and other. Here it mentions about Scrum. You can use Agile, Kanban as well. So Agile will minimize the risk of digital transformation in India, because Agile is to replace the waterfall method, which is having a high risk. Last is Agile. So if you would like to go for digital transformation in your organization and you want to fail fast or not fail at all, Agile is the way. Because in the waterfall method, you have 4 months to develop something and show. But in Agile, you can have a weekly incremental approach where you can collaborate with the stakeholders to change something. You don't need to wait. So minimum risk is 1 week. Okay. So Agile will be the way to go. And there are 2 Agile frameworks which are very, very successful and famous. Number 1 is Scrum, which is time-based. Another one is Kanban. So manager level and below, we use Scrum. Manager level above, director level, we use Kanban. And Intel, what they are using Agile plus OKR. OKR is basically for objective key results for your quarterly based KPI implementation. Okay. So this is a QR code that we would like to ask you to do, which will assist you to do self-assessment, and we will able to assist you free of cost about the report of your assessment. It's big, good and important question. Maybe you can able to do it.
Sharing the
Yes, we will be sending all of the speaker and my presentation to all of the participants. Any questions anyone have? If no questions, thank you very much. There will be a food, packed food for our Muslims and non-Muslim friends. So Muslim friend can able to book up also later, and then non-Muslim can able to proceed.